All right, so last session we started with S3 and we saw how to create S3 bucket. Okay, we talked about the levels of security in S3. Like we have three layers of security in S3, which is the account level security, bucket level security, and object level security, right? Also, we saw how to upload data to our S3 bucket, right? So we created this bucket in this one project, 7th of 6th. Yeah, and we uploaded some files into our S3 bucket. So any type of data basically we can store inside our S3 bucket, right? And we also talked about some limitations. Like in a AWS account, we can create up to 100 S3 buckets, right? And the max file upload size inside S3 bucket is of 5 terabyte, right? And we can upload through the console. Like we can upload a file up to 160 GB. Okay, we cannot upload more than 160 GB file through the console. Like from here, we cannot upload a file which is more than 160 GB. Okay. So to upload a file which is more than 160 GB, it is recommended by AWS to use AWS CLI. Okay. Also, we talked about bucket versioning. Okay. With bucket versioning, basically we can prevent accidental termination of our data, right, which is stored inside our S3 bucket. Okay. And now let us talk about static web hosting. Okay. So let's say if we have an application, okay, as you're a web developer. So let's say when we have you worked on Angular or React?
Yes. Mm-hmm.
Yeah. So when we do npm build prod, okay, npm run build prod. So basically, it generates static files, which are HTML files, HTML, CSS, and JavaScript files, right?
Yeah.
So those files, what we can do is we can upload it to our S3 bucket. So those files, basically, what we do, we upload it to a server, okay, server like EC2 instance, right? So instead of putting into an EC2 instance, we can create a S3 bucket and we can enable this feature of S3, which is static website hosting. Okay. So what we'll do is we'll create one bucket. Actually, we already have some data inside this bucket. So we'll just create a separate bucket. Here we'll click on create bucket. And for the uniqueness of name, as we know that the bucket name should be globally unique, right? And that's the main reason we call S3 as a global service. Okay, so far till now we have learned two global services, which is IAM and S3. Okay, later in the course we'll also learn about CloudFront and Route 53, which are also global services of AWS, which are part of this certification. Okay, so this is our bucket name, and we are going to create it in Virginia. Okay. And also we'll disable the bucket level security because we want to make the data which we are going to upload in our S3 bucket publicly accessible. Okay, because we are going to upload some website files. So we have to disable this thing. Okay, and as we are basically going to host our application code, so it is recommended that we enable versioning in our S3 bucket. So let's say in case by mistake if we overwrite a file, okay, so the application may get disturbed, right? So in that case, it is recommended that we enable bucket versioning. And then we click on create bucket. Yeah, so this is the bucket which we created, my web app. Now we'll upload our static files. Okay, So in S3 bucket, we have to upload, we can only host a static website. Static website, which means the website which has only HTML, CSS, or JavaScript. Okay, only those sites we can host using S3 bucket. Okay. Now let's say if you want to host a Node.js application, which basically is a server-side language, right? Like Node.js, PHP, these are all server-side programming languages. Okay, which means it requires a server to execute the code, right? So in that case, we need a EC2 instance, right? But if we just want to host a static website, just a one-page website, okay, or it can also have multiple pages, but it should be a static website. There should be no like dynamic. Okay, it doesn't have any dynamic features in it, right? So in that case, we can go with S3. Okay, if your application has let's say user want to sign up login, so in that case like we are going to use API. Let's say for login sign up we are going to use API, and let's say a database like MySQL, MongoDB, right? So in that case we'll require EC2 instance. Okay, okay, so I will just upload one sample application. Yeah, so here we have two files. One is an image file and one is index.html file. Okay. So what we'll do, we'll just clone this repository. You may have worked with Git, right? Hello? Tyler, can you hear me?
Hey, yes, I can hear you.
Mhm. Okay, so I'm just cloning one repository which has some static website, some JavaScript and some HTML files. It's index.html, and in this index.html itself, there is some JavaScript code. It has some CSS code, like HTML code. Okay, and it is before CSS. Basically, it is calling external files like from some other websites. Right? So we are just going to upload it to our S3 bucket. Now, let's say you have some files in your local machine. Okay, let's say right now I have some files in my local machine and I want to upload it to my S3 bucket. Okay, so one way is we can directly click on upload and we can upload it from here. Okay, another way is we can use the AWS CLI. Okay, we can use the AWS CLI. So first we have to configure the AWS CLI. So we'll run this command AWS configure, and we will just generate the IAM keys. So we'll go to users, and we'll just create one CLI user with programmatic access. And we will be directly attaching a policy, let's say S3 full access policy. But depending on our use case, we can create a separate policy, and that policy will define what kind of access the user, this API key will be having. Okay, so the user has been created, and we have the access key, secret access key. So we'll just copy this access key. Then the secret access key. The region, let's say our bucket is in US East 1. But region is not required because S3 is a global service. Then if we do AWS S3 LS, so what this command will do, it will list all the S3 buckets in our account. So recently we created this bucket, right? You can see it is created today. So we created this S3 bucket. Now what we want to do is we want to copy all these files to our S3 bucket, right? Which one? This one. So we can use AWS S3 CP command. Okay. Now all these commands we can get in the CLI documentation. Let's say if we go to AWS CLI reference. So here we'll just for service S3. Here you can find CLI command for all the services. So here we'll just look for S3. Yeah. Okay. Plus here we'll be able to see the commands which we can use. So let's say CP. Okay, then you can find the switches which we can use. Examples. Okay, so we'll just do AWS S3 CP, and we want to copy all the files. So asterisk. Sorry, AWS S3 CP asterisk, then the bucket name, and we have to give this thing. This is basically called S3 URI. Okay, this is called S3 URI, and then the bucket name. Valid length. Okay, here you can see it has uploaded this file hero.png, and this file is basically is going to be used inside our application. Index.html file is basically going to call this hero.png file. Then we are going to copy the index.html file. Okay. Okay, and we are good. So we have uploaded two files. Now if we go to our console, to our S3 bucket, and if we hit here refresh, so we should be able to see two files. And yes, we are able to see two files, hero.png and index.html. Okay. So first we have to upload our code to our S3 bucket. Then if we go to properties, we have to scroll all over down, and here we'll find a setting which is static web hosting. So by default it is disabled. We need to enable it. Okay. By default it is disabled. We need to enable it. And hosting type, host a static website. Okay, this is basically for redirecting request for a specific onto a specific object. Then we have to basically give the index file. Okay, index file or the file which we want to display when we are going to access the site. So we uploaded a file index.html. So here we'll give the file name index.html, and we also this is optional, which is error document. Like when we open a website and when we try to access a URL which doesn't exist, so basically it gives a 404 error, right? So it's basically asking us if we want to give a error document like of not found page, so that also we can give here. Then save changes. Okay, and if you scroll all over down now, so we'll be able to see the bucket endpoint. We'll just copy this, go to a new page. So currently it says access denied. Okay, so we'll be basically getting a custom URL for accessing the site. This is not the object URL. Okay, now basically it is giving us an error, forbidden, access denied. And the reason is the objects which we have are not public. Okay, currently they are not public. So we'll select all the objects, click on action, make public. Okay, once we do that, and if we hit refresh, so we'll be able to see the website, right? Okay, so this is basically just a static website which is on HTML, CSS, JavaScript. Okay, so and this is basically hosted in our S3 bucket. It's not running on a EC2 instance, right? If we are hosting it in EC2 instance, so there is basically we have to manage the server. We have to, and the costing will be also high in EC2, right? Whereas the costing in S3 will be very, very, very cheap as compared to EC2. Okay, so for hosting static websites, we can use S3 bucket. Okay, and if you want to use, if you want to host dynamic applications, okay. So let's say this is the application. This is the front end of the application. Let's say we want to deploy a mean stack application. Okay, so let's say this is the Angular application, and we have a backend of Node.js which is connecting to the MongoDB database, right? So in that case, we can host the Angular files to our S3 bucket, and we can host the Node.js server in our EC2 instance. And for database, let's say if the application is going to use MongoDB, so we can use AWS document DB database. Okay, we can use AWS document DB database. Document DB is not the part of certification exam, but just for, yeah, this one, fully managed MongoDB compatible database service. Okay. And if we are, if the application is going to use SQL database, let's say MySQL, so in that case we can use RDS service. Okay, we can deploy a MySQL RDS database, and Node.js server basically will be connecting to it, right? Do you have any questions?
Yeah, I was wondering, so it's totally public at this point, but if you were to say use CloudFront, is there a way to make it only accessible to like CloudFront at that point?
Yeah, we can do that. Yeah, we can make it completely accessible by CloudFront. Yeah,
Okay, and then it's not totally public; it's only accessible
through
from.
CloudFront.
Okay.
Yeah. Okay, we'll be seeing that when we'll be talking about CloudFront. At that time, we'll see how we can host the uh, website through CloudFront. Okay, CloudFront will basically do the caching part, and it will also make the access to the bucket more secure. Okay, so we just saw static web hosting. Now we'll be talking about encryption. Okay, before talking about encryption, let us talk about tags. Okay, so far we have learned almost 5 6 services, and almost all the times we used to skip tags. Okay, do you have any idea about tags?
Yeah, I think it's like an indexing service. Like you can look things up based on key throughout AWS.
Okay, did we talked about this in the last session?
Yeah, a little bit.
Oh. Yeah, so let's say it's basically for organizing the resources. Okay, let's say we have two projects running in one account. Okay, so let's say for every project basically we need, let's say, a VPC, we need couple of EC2 instances, RDS databases, right? We need EC2 instances, RDS databases, right? S3 bucket, right? Let's say in this project also we need the same EC2 instances, RDS database, S3 buckets. Right? So so let's say we want to organize the resources. Okay, we need to organize the resource. Let's say if we are running the same resources in the same account, so it will be very difficult to identify which resources in use in which project, right? So in that case, what we do is, at the time of creating each of these resources, basically we add a tag to these resources. Okay, and tag is basically a key value pair. Okay, so let's say we can create a tag, let's say project A, and for this resources we can create a tag, let's say project B. Okay, and now let's say we want to see what are the resources in project A. So there is one service of AWS which is, it's not a service but which is resource manager, sorry, resource groups. Okay, and in resource group we'll go to tag editor. Okay, so let's say this S3 bucket, I'll just add one tag to this S3 bucket, let's say project A. Okay, now what I want to do is I want to find all the resources which have this tag. Okay, so at the time of creating these resources, we will add a tag to each of these resources. Okay, for all the resources we can add a tag. Then here what we can do is we can do basically a search. Okay, search for resources which has this tag. Okay, so here you can see it is basically showing in S3 bucket which has this tag. Okay, so with tagging we can basically organize the resources. Okay, so at the time of creating VPC, EC2 instance, RDS databases, we can tag them. Okay, do you have any questions on tagging? Okay. Okay, so now we'll be talking about encryption. Okay, so by default, the data which we store inside of our S3 bucket is not encrypted. Okay, so when we just upload the data, it is not encrypted. Okay, and if we talk in terms of security, it is always recommended that we encrypt our data. Okay, any data which we are storing, we should encrypt the data. Okay, so S3 basically offers three types of encryption, not three, two types of encryption. One is server-side encryption, and another is encryption using KMS service of AWS. So if we click on here, so here you can say default encryption. By default, it is disabled. So here we click on edit, and we'll enable it. And once we click on enable, so here we can find two ways of encrypting the data. One is server-side encryption. Okay, where I mean the data which will be stored inside our S3 bucket will be encrypted. Okay, encrypted at rest. Okay, the data will be encrypted at the rest. At the time when we are going to retrieve the data, okay, at that time the data will be decrypted and we will be able to access the data. Okay, but if we are just storing the data at rest, the data will be encrypted. So that is server side encryption. Okay, SSE, server side encryption. And in this case, basically AWS creates the encryption key, and AWS basically manages the encryption. Okay, whereas another way we have is AWS KMS. Okay, AWS KMS is the key management service of AWS. Okay, if we go to KMS, okay, yeah, if you go to KMS, so this is basically key management service of AWS, where basically in this we have two types of keys. One is AWS managed key and one is customer managed key. And AWS managed keys are the keys which are created and managed by AWS. Okay, whereas customer managed key is created by us. Okay, and if we talk in terms of compliance, if we talk about PCI compliance or HIPAA compliance, so they basically recommend using customer managed key. Okay, they do not recommend us using AWS managed key. Okay, AWS managed key is because AWS managed key is created and managed by AWS, whereas customer managed key we have to create, and the keys are basically stored by us. Okay, and the keys are stored and managed by us. Okay, just give me 1 minute. Yeah. Uh, okay. Yeah. So we were talking about encryption. So we have two types of encryption. Okay. One is the AWS SSE, which is AWS server-side encryption. Okay, where encryption is done. I mean, yeah, where encryption is done by AWS, done, or we can say managed by AWS. Okay, and the second way we have is using AWS KMS. Okay, KMS is a separate service of AWS, which is key management service. Okay, and with KMS, okay, with KMS, what we can do is we can encrypt all the storage resources of AWS. All the storage resources of AWS. Okay, what are storage resources? Like we have S3, we have EBS, we have EFS, right? We have RDS volume, right? So all the resources which are related to storage, where we are storing something, where we are storing the data. So those services we can encrypt using KMS service of AWS, right? Those things we can encrypt using the we can encrypt using the key management KMS service of AWS. Okay, and we have two types of encryption available in KMS, which is AWS managed keys. I mean AWS KMS managed keys. Okay, and we have AWS KMS customer managed keys. Okay, in case of customer managed keys, the keys are managed by us. Okay, and here the key is managed by AWS. Okay, and if we talk about like which is recommended to use, so HIPAA compliance, PCI compliance, basically they recommend using customer managed keys, because customer managed key, in that case keys are managed by us. So the encryption decryption is managed by us. Whereas in this case, the keys are managed by AWS. So the encryption decryption is managed by AWS. And if we talk about server-side encryption, in this case also, the encryption decryption is managed by AWS. Okay, and by default there is no encryption. By default, encryption is disabled. Okay, by default encryption is disabled. So these are the two ways we have in AWS for encryption. One is AWS server-side encryption, and one is encryption using KMS. And in KMS, we have two options. One is AWS managed key encryption using AWS KMS managed keys. And another way we have is using AWS KMS customer managed keys. Okay. Okay. And by default, encryption is disabled. So if we go with this option, So here basically AWS creates the key and basically takes care of encryption. Whereas if we go with this option, so basically we have to give the key name. If we are going with AWS managed key, so AWS will automatically create a KMS key. Whereas if we are going to go with this option, choose from your AWS KMS keys, then here basically we can choose our customer managed key. Okay, and for that basically we need to create a key. So if we go to the KMS console, so here you can find AWS managed keys. So these are the keys which are generated by AWS, and these keys you will find are for all the storage services. Okay, like Elastic File System, which is basically a storage service. EBS is a storage service. ES is Elasticsearch. Backup service. Backup is also a storage service only. ACM is SSL service of AWS. RDS is the database where we are storing the data. FSX is the cluster file system. This is the cluster FS service of AWS. Secret manager, here basically we store any sensitive data. S3. So all the storage based service, here we can find the KMS keys. And these keys are created by AWS. These keys are created and managed by AWS. We cannot create a AWS managed keys. Okay. And when we start using, let's say, a storage service, let's say we are using RDS, so automatically AWS basically creates the key for us. Okay. By default, if we go to, let's say, if we go to some other region, and KMS is a regional service. Okay. So you have to basically choose a region for key creation. And another thing about KMS is, let's say if you have a S3 bucket in Virginia, so you should have, for performing encryption, you must have the key in Virginia region only. Okay, let's say if you created the key in some other region, let's say Ohio or let's say uh, California. So in that case, basically, you have to those keys you will not be able to use. So the key must be in the same region. Now let's say if you go to some other region, let's say Osaka. Okay, so here you can see we are not able to see any key here. But if we go to Virginia, we are able to see a lot of keys. And the reason is, in this region, we haven't created any resource. If we start creating any resource which is related to S3, so automatically AWS will generate a KMS key for us. Okay. But it is not recommended to use AWS managed keys. Okay. Because these keys are managed by AWS. Okay. And if we want to just encrypt the data, in that case we can go with AWS managed keys. Okay, where the data is not much sensitive, in that case we can go with AWS managed keys. If the data is very sensitive, like let's say credit card information or any confidential data, so in that case it is recommended to use customer managed keys. So to create a customer managed key, click on create key. Okay, so there are two types of keys which we can create. One is symmetric and asymmetric. So, sorry, symmetric and asymmetric. Symmetric key is basically one key through which we can perform both encryption and decryption. Whereas asymmetric key is like here we'll be having two keys. With one key we'll be able to perform encryption, and from the another key we'll be able to perform decryption. Okay. Okay, asymmetric key we can also understand it by like our SSH keys. In SSH keys also we have public and private key. right? So that is also a asymmetric key, and those keys are also encrypted, right? And our SSL certificates also we have public certificate and private certificate, two certificates, okay, through which basically encryption is done, right? So it is recommended that we use asymmetric encryption where we have pair of two keys. Then what kind of encryption we want to use? Okay, these are encryption algorithms. And AWS basically uses AES encryption. Okay, AES is the world's best encryption. AES encryption. AES. Yeah, advanced encryption system. Then here we can give a key name, which is basically the alias. Let's say my S3 bucket encryption key. Then next, then we have to define a key administrator. Okay, what is key administrator? A key administrator is the guy who will be having access to manage the key. Okay, manage the key, it means like delete the key or modify the permission of the keys. Okay, those things basically a key administrator can perform. So let's say we have a user, let's say we want to make Dave user as the key administrator. So Dave will be having access to delete the key and also will be having access to make any changes in permission of the key. Okay. Later we'll be basically see in KMS also we have KMS policy. Okay. So those policies or key deletion will be managed by the key administrator. Okay. So we are making Dave user as the key admin. Then allow key administrator to delete this key. If we disable this, so only the root user will be able to delete the key. Then key user, okay, like the user whom we want to allow to perform encryption and decryption, right? So let's say we want to allow user Bob and John to use this key for encryption and decryption. Okay, and here you can see basically the key policy. Like in IAM, we used to have IAM policy, right? And with IAM policy, we can manage access to the whole AWS account, like like what access on what service the user will be having, right? Same way we have KMS policy, and KMS policy is only applicable for KMS service of AWS. Okay, we can call it as a resource policy. Okay, there are a couple of services in AWS which have their own policies. Okay, like S3 also has bucket policy. Okay, those kind of policies are called resource policies. So S3 has bucket policy, KMS has key policy. Okay, so this is basically the key policy. Okay, so the key has been created. And here we can see the permission, which user will be having what permission. Okay, and here we can see the public key, okay, which is used for encryption purpose only. Okay, do you have any question in KMS?
No. I am curious as to in what circumstances you would choose server-side encryption over KMS or vice versa.
Yes, server side encryption is for, let's say, if you want to host a static website, or you're just storing some general data like PDF documents. So in that case, we can go with server side encryption. Now, let's say if you are storing any confidential data, or any data which is a sensitive data, right? So in that case, it is recommended using AWS KMS. Okay, and in KMS, it is recommended to use customer managed key. Okay, because here the keys, encryption and decryption is managed by us, whereas in AWS managed keys, the encryption and decryption is managed by AWS.
Okay.
Okay, so we are currently, we are encrypting it by server-side encryption. So any new data which will be uploaded in our S3 bucket will be encrypted by this key. Okay, because here we are enabling default encryption. So any new data which will be uploaded will be encrypted. Okay, the data which we have currently will not be encrypted. Only the new data which will be uploaded will be encrypted. To encrypt the existing data, we have to manually encrypt it. Okay, we have to manually encrypt it, or we can do it by the AWS CLI also. Okay, so now if we click on any of the object, and if we click on, so if we click on this object, and if we see the encryption, yeah, so encryption is disabled. So manually we have to enable the encryption. Let's say enable server side encryption. Then through which mechanism we want to encrypt the data, and then save. This is manually encrypting the data. Okay. At the time of creating the S3 bucket, at that time also we can enable encryption, default encryption. So any new data which will be uploaded, let's say if we try to upload uh, some files. So now this file will be encrypted because we have enabled default encryption in our S3 bucket. Okay, do you have any questions still here?
Yeah.
Okay. Okay, now let us talk about storage classes. Before talking about intelligent tiering, let us talk about storage classes. Are you familiar with storage classes?
So this is, are these like life cycle tiers, like it'll keep it for a certain amount of time type of thing?
Yeah, this actually defines.
Oh yeah, yes, I'm familiar with these. So
Yeah,
it
this is.
depends on which one you have, like how quickly you can retrieve the data, how long it's stored before deletion, things like
Yeah. So basically, we have 6 types of encryption. I think it will not be. This image is not clear. Yes. Yeah, so we have 6 storage classes in S3. And storage classes basically defines how the data will be stored inside our S3 bucket. Okay, like it depends basically upon our use case, like how oftenly we are accessing the data. Okay, so depending on that, basically we can switch over the storage classes. Okay, and storage class basically defines in what kind of hardware our data will be stored. Okay, like if we are going to store the data in SSD. Okay, so SSD is basically expensive hardware, right, as compared to SDD. Okay, in SDD, the read write speed is less, right, whereas in SSD the read write speed is high, and SSD is more expensive than SDD, right? So these storage classes are nothing but basically they are defining the underlying hardware. Okay, now depending on our use case, basically we have to choose these storage classes. Okay, so we have 6 types of storage classes: S3 standard, S3 intelligent tiering, S3 standard IA, S3 one zone IA, S3 glacier, S3 glacier deep archive. Okay, if we so basically we have 3 types of storage classes. If we talk in general, if we don't talk in terms of AWS, so we have 3 types of storage classes. One is hot tier, one is warm tier, and one is cold storage or cold tier. Okay, we have 3 tiers of storage: hot, warm, and cold. So this S3 standard is hot tier. Okay, what basically is hot tier? In where basically there is, the frequently accessed data. Okay, let's say we have a website and that website is using the S3, the images which are stored in our S3 bucket. Okay, and let's say there are almost 100, 200, or thousands of hit on the website. Okay, so in that case, basically that is the frequent access, right? Like in a day there are thousands of requests on the website, and website is basically fetching the images from the S3 bucket. So in that case we can go with S3 standard. S3 standard is basically designed for frequently accessed data. Okay, and if we talk in terms of pricing, this is the most expensive and this is the cheapest. S3 glacier S3 glacier is the cheapest, whereas S3 standard is the most expensive, and it's basically designed for frequently accessed data. Okay, and choosing these storage classes basically completely depends upon our use case. Okay, so if we are going to use it for our S3 bucket, for a website which will be going to access the static file images from the S3 bucket, so in that case we are going to keep it in S3 standard. Okay, and S3 standard is expensive, plus the retrieval time. The retrieval time of S3 standard is instant. Okay, whereas if we go at the right side, so the retrieval time basically keeps on increasing. Okay, so in S3 standard, the retrieval time is very less. Okay, and here we can see the use case also they have given, like where we need the data active, frequently accessed data, right? And here you can see the access. The access is millisecond access, and then 3 AZ. It is basically written greater than equal to 3 AZ. So this basically means when we are uploading our data to our S3 bucket, it will be replicated across 3 availability zones, so that there will be no data loss. So let's say when we uploaded this file to our S3 bucket, let's say this file we have uploaded. So currently we are assuming this file is in Virginia region. That is right, but it is replicated across 3 availability zones. So in 3 availability zone, basically AWS is storing our data. Okay, so that we don't so that our data is not lost. In case of any of the availability zone failure, the data will not be lost. Okay, so if we talk in terms, I mean, in this storage class, we are also getting high availability for our data, because the data is stored across multiple availability zones. Okay, where the minimum availability zone is 3. And if we see the pricing, so this is the pricing. Okay, 0.0210 per GB. Okay, this is the most expensive as compared to if we see other pricings. So S3 intelligent tier is not a storage class. We'll talk about this. Then if we talk about this S3 standard IEA, okay, IEA is basically infrequently accessed data. If we see the pricing, so it is almost half, right? Then if we see S3 one zone IEA, it's more less. Then here it is very less as compared to this one, and this one. And here in S3 Glacier, it is the cheapest. Okay, this is the cheapest. Okay? And this is basically per GB charge. Okay, this is per GB charge, per GB of data stored inside our S3 bucket. This is the charge. Okay, now we'll be talking about S3 standard IA. We'll come back to this one. This is basically for if we are not sure about in which data in storage class, in which storage class we should store the data. So in that case, basically we use intelligent tiering. Okay, so we have S3 standard IA, which is basically used for storing data which is infrequently accessed. Okay, so like the data which is accessed, let's say once in a day or once in a week, okay, or once in 15 days. So that kind of data we can store in S3 standard IA. Okay, and it is almost half, 50% half, almost 50% off of S3 standard. Okay, so if we have any data which will not be frequently accessed, so in that case we can store it to our S3 standard IA storage class. And here also the data is replicated across 3 availability zones. Okay, and this is the price. Okay, but here we have a retrieval fees also. When we are going to download the data, retrieve the data from the S3 bucket, so there is a retrieval fee per GB. Okay, also here we have minimum object size that we can actually. Okay, in the certification exam, mostly there will be scenario questions in S3. Like they will be basically giving you a scenario saying that the company wants to host their images into S3 bucket, and they have to choose a storage class, and the data which will be stored inside the S3 bucket will be accessed almost, I mean, which it will be frequently accessed. Okay, so which of the storage class should the company use? Okay, so if the question is talking about frequently access, so then we will be going with standard. Okay, also in the certification exam there will be questions related to durability and availability. Okay, so these are the numbers basically which we have to memorize, like this number. Durability is same for all the storage classes. RSS is not now not in use, which was reduced redundancy storage class. It's no longer in S3. So durability is almost same for all the storage classes. And if we talk about availability depending on the storage class is different. So here you can see for standard it is this, for standard IA it is this, and intelligent tiering also it is this. And one zone IA it is 99.5. For Glacier also it is the same as standard. So this number basically we have to remember. Okay, they can directly ask like what is the availability of one zone IA storage class. Okay, and there will be option like 99.9, 99.9, 99.5, 99.99. These will be the options. Okay, so this is this is something basically we have to remember, the numbers, the percent. Okay. Then there could be a question of availability zones. So all the storage classes, basically the data is replicated across uh, 3 availability zones, right? Whereas in one zone IA, it is only replicated across only one availability zone. Okay, the data is only replicated across one availability zone. Okay, then we have storage duration. So this storage duration is also a number we have to remember. It can be asked in the certification exam. Let's say what will be the minimum storage duration of standard IA. Okay. Then billable object. Okay, so let's say if we are storing a file which is less than 128 KB, so we'll not be charged for it. If we are going with standard IA, so we'll not be charged for it. Okay, so if we are storing any file of 128 KB, 40 KB, 40 KB, so we will not be charged for it in these storage classes. Whereas in standard storage class, we will be charged for that. Okay, and if we see for in terms of use cases, so it's basically designed for frequently accessed data. And this is basically for long-lived, infrequently accessed data. Okay. And then intelligent tiering. So an intelligent tiering, basically, let's say if we are not sure, let's say we have created an S3 bucket and we have uploaded our data and we are not sure which storage class to use, whether to use the standard storage class or whether to use the standard IEA class. In that case, basically we choose intelligent tiering. So what AWS does is AWS basically see the access, okay, like how frequently the data is being accessed. If it is basically accessed frequently, then it basically changes the storage class to standard. Whereas if it is not frequently accessed, it will change the storage class to standard IA. Okay. Then we have one zone IA. Okay, let's say you want to store the data for a longer period of time, plus you want a you want a cheap storage. Okay, you want to store some data which is not sensitive or which is not which is not which is not much important. Okay, which is not important, plus you need a a cheap storage. Okay, so in that case we can go with one zone IA. Okay, here basically it is very cheap as compared to standard IA and standard storage class. It is very cheap, and the reason of this storage class of being cheap is the data is replicated across only one availability zone. Okay, and here basically we have chances of data loss, and here we can see that data availability is also less. Okay. Then we have Glacier. Okay, Glacier is basically, we can say, it's basically a cold storage, and here basically if you want to store the data for a longer period of time, so a longer period like 6 months or for a year, okay, or for 1 year, 2 year, okay, like we basically usually store data like backup. Okay, backup we do not usually access, right? Or there are some companies like healthcare industries or payment industries. Basically, they keep the data of customers of last 5 years. Okay, 5 years or 10 years. So in that case, basically we use these services: Glacier and Glacier Deep Archive. Okay, and here in Glacier, basically, it is very cheap as compared to other storage classes. But the problem with Glacier is, let's say if you have stored your data in a Glacier, so you cannot instantly retrieve your data. Okay, whereas in S3, you can, let's say once you have uploaded, you can download the data instantly. Whereas in Glacier, you cannot download the data instantly. Once it is stored in Glacier, so there basically is a retrieval time. Okay, here they haven't given, but for Glacier there is the retrieval time. For just for Glacier it is 0 to 6 hours, and for Glacier Deep Archive it is 12 hours. Yeah, here it is written also, like long with retrieval times ranging from 1 minute to hours. Hours is basically 6 hours, and Deep Archive is up to 12 hours. Okay, so let's say if the company wants to store, like healthcare industry or payment industry, they want to store data for a longer period of time. Let's say 10 years. So in that case, we can go with Glacier Deep Archive. Okay, Glacier or Glacier Deep Archive. But the data retrieval is not instant. Okay, let's say the customer request for a report, let's say of 5 years back or 10 years back. So it will take, depending on which storage class we have used, let's say Glacier or Glacier Deep Archive. So it will take some time to retrieve the data. Okay. Do you have any questions till here?
Yeah, I'm trying to remember. I think, isn't there a way to expedite retrieval of the Glacier service?
Sorry?
Isn't there a way to expedite the retrieval? Like if you pay additional fee or something for Glacier?
Yeah. There is. So let's say if we upload a data, let's say if we upload a file, yeah, there will be additional charge for retrieving the data then. Let's say we are uploading this XLX file, and at the time of the upload itself, we can set the storage class. Okay, let's say we want to store it to Glacier Deep Archive. If you want to encrypt, we can encrypt it, then upload. Okay, so we have uploaded the file, and here you can see the object is stored in Glacier Deep Archive, and now we want to restore it. So if we click on Initiate Restore, so let's say if we want to retrieve a lot of files, okay, let's say we want to retrieve hundreds of files. So in that case, we can go with bulk retrieval, and bulk retrieval basically will take a lot of time. If we go with standard retrieval, it will take 12 hours. So in that case, let's say we want to retrieve this file in 12 hours. And here basically we have to set a expire time also for the data. Okay, let's say once the data is retrieved, let's say we want to delete it in 10 days. So that date also we have to set. And after that, S3 will automatically delete it. Okay, yeah, the way, I mean, okay, this one we have stored in deep archive. So here basically it was not showing any option. Let's say if we upload into the just to the Glacier storage class, say this file. Initiate restore. Yeah, so let's say if we want to, yeah, here we have the expired retrieval. So here basically we have to purchase PCUs, which is provision capacity units, okay, which is basically the read write performance which we have on the disk. So if we are going to purchase that, so based on that, basically the data retrieval will be little faster. Yeah, so this data retrieval speed will be increased up to 150 Mbps. Okay, and the data which we store in the standard storage class, basically the speed basically ranges from 400 megabytes to GBs. Okay, because there the data is stored inside SSDs. Okay, do you have any questions till here?
No, we can continue.
Okay, so the next thing we have is server access log. Okay, so currently, like the data which we have inside our S3 bucket, we don't have any track like who is accessing the data. Okay, accessing the data over the internet. Okay, over the internet, let's say we are accessing any data which is stored inside our S3 bucket. Let's say okay, let's say this is a PDF file. So we'll just make it public. Now let's say we want to track the downloads of this file. Okay, let's say we want to see who has downloaded, what time the file was downloaded, and from which IP the file was downloaded. Okay, so let's say this link of this file we have added to our website. So when the user clicks on download button, this PDF file is downloaded. Now we want to track the downloads. Okay, track the downloads or access. Right. So in that case, okay, in that case, we can enable S3 server access logging. And what server access logging does is it basically stores the data inside. It basically start creating the logs. Okay, let's say this file we have made public. Now if we go here, server access logging, edit, enable, and here basically we can give the bucket path. Not the bucket path, I mean here basically we have to give the destination bucket where we want to store the log files. Okay, where we want to store the log files. So we can also create a separate bucket dedicatedly for storing the logs. So let's say for example we have one bucket S3 log. Okay, and inside this we can create a folder. Let's say Let's say project A logs, cross location. Yeah, so actually this bucket is not in the same region. Okay, so the bucket must also be in the same region. So let's say the current bucket we have is in Virginia. So let's say this one. We'll go with this bucket. Okay, so if we go here, server access logging, so it is enabled and it is storing the data inside the logs inside this folder. Now let's say if we access this file, let's say this file which we are accessing, so it will now start generating the logs. And those logs are not generated instantly, it will take 5 minutes. Let's say we are accessing this file. Now if we go to that S3 bucket, let's say this one. Okay, so in some time it will start, generating the log file. So it basically takes 5 minutes, and after 5 minutes, we'll be able to see the log file here. And that log file will be basically having the user's IP address, the time when the file was accessed, the object name, and other information. Okay, it's just a log file which will be having the trace of at what time the file was being accessed, from which IP, and which file was accessed. Okay, and this is very useful to keep a track of the access of the files, at what time it was accessed, from which IP it was accessed.
Is this at an additional cost or is this a free service?
It's a free service. We are only charged for the log files, I mean the data which is stored.
Okay.
Okay, actually there should be one bucket. Yeah, just to show you how the log look like. So let's say this is the log file. I mean, this kind of file will be generated. Let's say if we open this, let's say make public. This is denied. Yeah, so this is the log file. I just downloaded it from the S3 bucket. Yeah, so here you can see the trace, like from which, yeah, here you can see the object ID, the bucket name, what time of the event, let's say date and time, the IP address, and by which way it was accessed. Okay, it is basically an assume role. Then what event happened, like put is basically the upload operation, and put in this file, right? Yeah, so these kind of logs are generated basically. It basically has a trace at what time which file was accessed, downloaded. Okay, then we have CloudTrail data events. So CloudTrail, did we talk about CloudTrail?
Yeah, it tracks API.
API activities. Yeah, user activities basically. I am user API activities. Yeah, so basically it tracks for only IAM, and let's say we want to track it for a specific S3 bucket. So in that case, yeah, you can see, I mean, it tracks for S3 bucket also. Not S3 bucket, it's basically for S3 service. So here basically we can see all the operations like accessing the EC2, EC2. I mean, let's say through the root user at what time, what event happened. Let's say event name, run instance, at what time, by which user, an event. So this is the API name, ec2.amazon.aws.com, and which resource, and then the resource name also we have. Okay, so this is basically for all the services. Now let's say we want for a specific service. Okay, we want for a specific service. Let's say we want for just for S3 bucket. Let's say we want only to create the access events of this S3 bucket. The one which we saw, which was server access logging. Server access logging was for external. Okay, the access which was outside of AWS. For that, basically, we had server access logging. For access inside the AWS account, like inside the AWS account, only IAM users can access, right? Because only IAM user can log into the account and then access the data, right? So in that case, we can create a cloud trail. Okay, we can create for a S3 bucket. Okay, then in which bucket we want to store the logs, so we can store it in an existing bucket, or we can create a new dedicated bucket for that. So we'll go with a new bucket. So here we'll just add AWS project A. cloud trail logs. And then if you want to encrypt it, encrypt the log file, that also we can do. We'll not go with encryption because in that case, basically we need to update some policies, bucket policies. Then CloudWatch log is basically a complete different service of AWS. And then what kind of events we want to write inside the, to our S3 bucket. So let's say we want to write data events. So if we go with data event, so it will ask us for the data source. So here we have three types of data events: S3, Lambda, and DynamoDB. We'll go with S3. Then for which bucket, if you want to do for a specific bucket, that also we can do. It's basically currently for all the buckets. So let's say we want to do it for our project A bucket. Next. And for read and write event both. Next. And create. Now any kind of IAM access will be stored inside this S3 bucket. Okay, now if we go to this bucket, yeah, here you can see the bucket has been created and any kind of access in this bucket, project A bucket, at the account level. Okay, at the account level means at by IAM users. Okay, now let's say if I go to this bucket and if I uh, open this object, like I'm reading this object. So in that case, this there will be an event tracked, and that event will be stored inside this bucket. By which user the event was created, what time it was created, which region. No, no, this is not our S3. This is different bucket. Yeah, this is the. Okay, right now it has not generated any events. It will take 5-10 minutes for it to start generating the events. Okay, just to see the sample logs, if we go to this bucket, yeah, this is basically how it looked like. It's a compressed file, compressed JSON file. Yeah, here you can see the event. Let's say, yeah, here you can see this is one event JSON we can see in JSON. So let's say the event is by user root, user identity. Here you can see root, which account, ARN, account ID, access. This is basically by API key. So the API key name and the username. Username is basically the account name. Then from which IP it was accessed, what operation was performed, and from which machine it was performed. Let's say it is giving the operating system also, Linux machine. The bucket name, how many file listed, which region. So basically, this is the IAM access event, from which user it was accessed, what time it was accessed. Those things basically we can get using CloudTrail. For this bucket, it will take some time, and after some time, it will start generating the logs. The events are, I mean, the events are logged after every 5 minutes. Do you have any question?
Nope.
Okay, now let us talk about event notification. So when we upload any data, when we access any data, or when we delete any data, so everything is basically a event. Okay, like upload event, delete event, access event, right? Now on a specific event, we want to perform some operation. Let's say if someone is deleting the data inside our S3 bucket, so we want an alert that someone has deleted the data from our S3 bucket, and we should get the let's say from which IAM user this event has happened, and from which account this has happened. Okay, from which IP at what time it happened. So basically, we can create a event notification. Okay, let's say event name. Let's say access event. Or let's say delete event. Or let's say upload event. Then prefix. Let's say the image name. Not the image name. I mean, if we want to set it for a specific folder. Okay, prefix is nothing but a folder in S3. Okay? So if we want to do it for a specific folder, so here basically we can give the folder name. Okay, if you want to do for the entire S3 bucket, so we don't have to specify any prefix. Okay, suffix also we can specify. Suffix is basically the extension, file extension like JPG, EXE, PNG, PDF, doc, right? Then on what kind of event we want this, we want a trigger. So let's say, or sorry, we want a notification. So let's say we want for all upload events. Okay, here you can find restore object event, delete events, all objects create events. Okay, create basically has upload, copy, right? Then what source we want to trigger. So here we have three destinations: Lambda function, SNS, and SQSQ. Okay, we have Lambda function, SNS, and SQSQ. So Lambda function is basically, are you familiar with Lambda?
Yeah, some serverless.
Yeah, it's basically a serverless service through which we can. Oh, just give me 1 minute. One server is down. Yeah, sorry. Okay, so we have Lambda function, and Lambda function is basically a serverless service of AWS. And with Lambda function, uh, like if we okay, so let's say we have a Python code. Okay, do you know Python?
What was that?
Python. Do you know Python? Python.
Oh, Python, yeah.
Yeah. So let's say if we want to run a Python application, so we need. There are two things we require. So one, we need a computer, okay, like a laptop or a desktop, and we need a compiler, right? We need a Python compiler. Two things we need. We need a system and we need a compiler, which will be compiling the program and which is going to run it, right? So in that case, okay, so we need a compiler which will be compiling it and running it. So there are two requirements. One, we need a system and we need a compiler, right? So let's say if we want to run the Python program in AWS, so in that case we have to launch a EC2 instance. We need to install Python compiler in that, and then we'll be able to execute the Python program, right? And if we are going to launch a EC2 instance, then we have to manage the EC2 instance. Plus, there will be hourly charge of the EC2 instance, depending on which purchasing option we have used, right? And let's say we want to run that program once in a month, or once in a day, we want to run it, right? And if we are keeping the instance 24/7 up and running, so it will be a lot of charges will be there, right? So instead of that, we can use AWS Lambda. Okay, AWS Lambda, we can say it is a serverless service. It is we can say platform as a service. Okay, where we just need to provide our code, and AWS will basically run the code. Okay, run the code for us. Okay, in the background, they will be basically having their own servers. They will be having the compilers which they are going to run, right? So let's say in S3, what we can do is, like, let's say when a upload event is happening. So let's say if someone is uploading a zip file, and what we want to do is, once a zip file is uploaded to the S3 bucket, we want the zip file to be automatically extracted and it should be deleted. The zip file must be deleted first, extracted. I mean, extracted means the content which must be uploaded to the S3 bucket, content of the zip file, and the zip file should be deleted. Okay, or any kind of other operation we want to perform. Let's say there is an image, we want to resize the image, or we want to compress the image. When the file is uploaded, the image is uploaded, we want to compress the image, right? So in that case, we can use lambda function. Okay, and in lambda function, first we have to create a lambda function. Okay, let's say we can create a lambda function, let's say in Python. Okay, currently the UI of lambda is completely changed. So basically we can create a lambda function. Okay, and these are the programming languages which are supported. Here we have .NET, we have Go, we have Java, we have Node.js, Python, and Ruby. And we have also support for some other programming language. I mean, some older versions of these programming languages. Okay, and here if we don't have the programming language which we want, let's say PHP is not here. So in that case, we can have a custom runtime, which will be running on Amazon Linux 1 or Amazon Linux 2. Okay, where we can do some installation and we can run our own application code. So let's say Python. Okay, let's say my free event lambda create function. Okay, so the lambda function has been created. Okay, so here basically we have to write the code. Okay, and that code will be basically doing some operation. Like with coding, we can do anything. Like we can, let's say the file is uploaded and that file data we want to upload it to a database. Like we want to keep a track of files which are uploaded into our S3 bucket to a RDS database. So here we can call the RDS API, or we can perform a insertion option. I mean insert operation through the Python API. Okay, not Python API, both Python libraries, which will be connecting to the RDS database and appending data to a table inside the RDS database, right? So any kind of operation basically we can perform using lambda function. Okay, so let's say once we create the lambda function, we can provide the lambda function name here. So whenever the upload event is going to happen, it will trigger this lambda function. And this lambda function will be performing an operation depending on our use case, like compressing the file, extracting the file, or resizing the file, right? Okay, so once that event happens, it will automatically trigger the Lambda function. And we can actually also see here in Lambda functions the linked S3 bucket. That also we can see. Yeah, here you can see the linked S3 bucket. So this is the bucket which we have just linked, right? Here, which was project A bucket. So this is basically the trigger. Any file which is uploaded here, it will trigger the Lambda function. Lambda function then will perform some operation. Okay, we can also add notification, a notification which will be calling some other Lambda function, or it will be calling, I mean, it will be sending a notification whether the Lambda function succeeded or failed. Okay, do you have any questions still here? Also, we can create a notification also. Like here, we can add a SNS notification. SNS is basically a notification service of AWS, simple notification service, with which we can get email notification. Yeah, do you have any question?
No.
Okay. Okay, so then we have transfer acceleration. Okay, transfer acceleration is basically used. I think we talked about transfer acceleration. Did we?
I don't think we did. We talked about
Okay.
expert retrieval, but I think that's different, right?
Yeah, so transfer acceleration is, let's say we want to upload a very big file. We want to upload a file, let's say a file we have which is of 500 GB. Okay, and we want to upload it to our S3 bucket. So, so depending on our where we are located, let's say if someone is in Australia and want to upload a file to a bucket which is in Virginia. Okay, so there, in terms of geographic locations, so both the places are very far, right? So there will be latency, right? And also it depends upon the user's internet connectivity. Okay, like in internet connectivity, also we get the bandwidth, like 10 Mbps speed, 100 Mbps, right? That kind of speed basically we get. Now with transfer acceleration, there is one. There is one comparison page where we can see the speed comparison. So once we enable the yeah, once we enable the transfer acceleration feature in our S3 bucket, so depending on the region, basically AWS provides some endpoints through which the transfer speed is minimized. Okay, now let's say if we are uploading a file directly through the S3 to the AWS CLI or through the AWS console, let's say in Virginia, so it is going to take this much amount of time. Okay, actually we'll be able to see the comparison, and if we upload it by S3 accelerated transfer, I mean that setting, so then it will show what will be the speed. So it is 22% faster. If we are enabling accelerated transfer, it will be 22% faster. as compared to the direct upload. Okay, but with accelerated transfer, there are additional charges also. Then for other regions, I mean, we have comparison for all the regions, but it could be faster also, and it could be slow also, depending on the region. It can be fast also, it can be slow also in some cases. Okay, for this region, it is 56% faster. Okay, so if you want to do bulk upload, or if you want to upload big files to the S3 bucket, so in that case, we can go with accelerated transfer. Okay, the upload speed will be faster with this option. And if the upload speed will be faster, the data will be uploaded much faster. Okay. So let's say for San Francisco region, if we are uploading a file of 1 GB, so that file will be, let's say if we are uploading it by direct uploaded, let's say it is uploaded in 30 minutes. And if we are going to upload it with accelerated transfer, so it will be just uploaded in 14-15 minutes. Okay, as it is 56% faster. So depending on our use case, we can enable or disable the transfer acceleration. Okay, then we have object lock. Okay, object lock is a feature which is uh, like it's basically for accidental deletion of data which we have stored in we have in our S3 bucket. Let's say we are storing data inside our S3 bucket, and someone by mistakenly deletes the data which is stored inside the S3 bucket. Okay, and if it is deleted, then it cannot be retrieved, it cannot be recovered, right? So in that case, we use object lock. And with object log, if we enable object log on the S3 bucket, so even the root user cannot delete the object. When we enable object log, we have to basically set a time. Let's say 60 days. When we are uploading, creating the bucket, let's say we have set 60 days as object log. So in that 60, at that, I mean, in those 60 days, the data will not be, it cannot be deleted. Any data which is uploaded will not be deleted for at least 60 days. Even if the root user tries to delete, it will not be deleted. Okay, so it basically prevents accidental termination. Okay, and currently if you want to enable, so we cannot enable it. This feature can only be enabled at the time of creating the S3 bucket. It cannot be enabled after creation of the S3 bucket. So if we go here, buckets, create bucket. So here you can find in advanced settings, object lock. So it cannot be it can only be enabled at the time of creating the S3 bucket. After creating the S3 bucket, we cannot enable this option. Okay, do you have any questions till now?
Nope.
Okay, okay, let's have a break of 5 minutes and then we'll continue.
Okay,
Okay.
sounds good.
Yeah. All right. So okay, so we talked about S3 bucket policies properties. Now we'll talk about permissions. Okay, so there are two types of permissions which we have in S3. One is through bucket policy, and one is through ACLs. Okay, what are ACLs? ACLs are access control list. Okay. And bucket policy is basically like a IAM policy. Okay, bucket policy is also, we can call it as a resource policy. Okay, there are a couple of services in AWS which have resource policies like S3, like KMS also we saw today, and in SNS also has its own policy, and SQS service that also has its own policy. Okay, so there are some services which have their own policy, which is called resource policy. So the same way in S3 we have bucket policy. Okay, with bucket policy, basically uh, we can perform some operation. Let's say we want to make the entire bucket public. Okay, currently, let's say if we upload any object inside our S3 bucket, by default it is not public unless we make it public manually. Right now, let's say we want to make our whole S3 bucket publicly accessible. Let's say our S3 bucket is only storing images and we want to make it publicly accessible. So in that case, we use bucket policies. Or let's say we want to make the bucket publicly accessible, but we want to make it accessible for a specific object. I mean, for a specific domain. So that only if the requests are coming from that domain only, then only the access will be granted, or else the access will be denied, right? So in that case, we can use bucket policy. There are some sample policies. Sorry. Yeah, so these are some of the common use cases, like granting permission to multiple accounts, like cross account access also we can give um, using the bucket policy. Grant read only permission to anonymous user, limiting access to specific IP addresses. Okay, adding a bucket policy to require MFA. So these kind of operations we can perform using the bucket policy. Okay, whereas these kind of operations we cannot perform using IAM policies. Okay, and hence we have resource policies for some services. Okay, IAM can only perform the access management, who will be able to access the S3 bucket, and what S3 bucket the user will be having, IAM user will be having access to, and in which bucket and what object he will be having access to. Those things we can manage using IAM. Whereas, let's say we want to manage who can access, I mean, what access will be, I mean, let's say we want to give cross account access, or we want to uh, make the S3 publicly accessible. Those kind of operations we can perform using bucket policy. Okay, so here are some examples of bucket policy, like commonly used bucket policies, like granting permission to multiple AWS accounts. Okay, then what kind of access we want to provide. It is, if we read this policy, it is same as the IAM policy which we learned. Like here we can see three main points, like effect, action, and resource. Like in IAM policy also we have the same things, right? But this policy is only going to talk about S3, whereas IAM policy talks about all the services, like allow access. Okay, SID is just a description. Then allow access to what resource? This resource. And then in that resource, this is the bucket ARN. And in that resource, what kind of operation should be allowed? Like put object. Put object is uploading the object, uploading the data to the S3 bucket. Put object ACL. Put object ACL is applying, making changes in the ACLs. Then it is basically, here we have a condition which is that the only access which will be granted is public read, and this will be granted to these principals. Whenever we are talking about principal, we are basically talking about cross account access. So these are the account IDs whom we are granting this access. Okay, granting read-only permission to an anonymous user. So this is basically making the S3 bucket publicly accessible. This policy will make the S3 bucket publicly accessible. Without bucket policy, we cannot do this thing. We cannot make the S3 bucket publicly accessible without bucket policy.
So, but isn't there a setting where you can just click that you want it to be publicly accessible without creating a policy?
No, there is no setting.
When you're creating a bucket, it's private by default, but then if you click I forget what it is. There's a bunch of associated that, yeah, block public access, and you turn that off. Doesn't that then make it publicly accessible?
No. It makes the bucket access open, but it doesn't make the bucket publicly accessible. Let's say
Yeah.
bucket is publicly accessible, but the data which is stored inside the bucket will not be accessible.
Oh, okay.
Yeah. So with this, basically the data which is stored inside the S3 bucket becomes publicly accessible. Okay, let's say we apply this policy. So currently, let's say this is our bucket. Okay, let's say this is the PDF. I think we made this publicly accessible. So let's say this is a image, and we want to access this image. So with this URL, we'll be able to access it. Okay, so currently it means it is publicly accessible. So we'll just upload one image file, and by default it will not be publicly accessible. Right? Let's say upload, add files. Yeah, let's see this file and upload. Okay, the file is uploaded. And if we try to access the file using the object URL, it says access denied. Right? Now let's say if we apply the bucket policy. So bucket policy, this bucket policy, which is basically granting read-only permission to any anonymous user, which is basically making bucket publicly accessible. So here we just need to provide the bucket ARN. So here we'll just key in the bucket ARN and then save changes. And once we do that, that file is now publicly accessible. Right? Earlier we were getting access denied error. Now any file which we upload to our S3 bucket will be publicly accessible. We don't have to explicitly go to that file and make it manually publicly accessible. So currently all the data which is stored inside our S3 bucket is publicly accessible. Okay, so this is the file which we just uploaded. So here you can see this file is also now publicly accessible. Okay, and here you can see one red button which says the bucket is now publicly accessible. It's basically giving us a warning. The bucket can be accessed by anyone on the internet unless you require a public configuration for a specific use case. AWS recommend that you block all public access to your buckets. Okay, so with bucket policy only we can do this kind of operation. Okay, like granting cross account access. Okay, another good use case is like here, yeah, with this we can also limit access to the to a, let's say, a certain country. So we can just provide the IP address range of that specific country. So if the request to access the object is coming from that specific IP address, then only it will be allowed. Okay, or else it will be denied. So we can, with bucket policy, we can do that also. Restriction also we can do. We can do for both IPv4 and IPv6 address. Okay, we can restrict that access of the data for a specific domain also. Okay, this is a very useful policy. Let's say if we have some data which we have stored inside our S3 bucket, and we want our application, our website, to access those images. Okay, okay. And we only want that the if the request is coming from our application, then only it should be accepted or it should be accessed, right? And if it is originating from some other domain, let's say some other website is trying to use our images which are stored inside our S3 bucket, and if you want to restrict it, so in that case we can use this bucket policy, and we can give here the domain names. Okay, the domain names on which we want to grant access to. Okay, this is for CloudFront. Okay, but when we create CloudFront distribution, this policy is automatically created and applied to this three bucket. Okay, do you have any question in bucket policy?
No.
Okay, then we have ACL. ACL is more for, let's say, it's more for cross account access. It's more for account level access. Okay, level access, and yeah, it's more for access management. Whereas with bucket policy we get a lot of other features. Access management we can do with bucket policies also, but with bucket policy we get more advanced features. Right? We can restrict access to a specific IP address. We can restrict access to a specific domains. But those things we cannot do using ACLs. Okay. Like bucket owner, the AWS account, what access it will be having, everyone public access who will be having what access over the internet, what access the users in this account will be having by default. S3 log delivery group, that is basically uh, where the S3 bucket event logs are generated. And if you want to grant access to some other AWS account, so we need to provide the canonical ID. Okay, like we have account ID, right? The same way we have a canonical ID, which is for every AWS account. Okay, to get this canonical ID, if we go to my security credentials, and this can only be found in the root account. So we have to log in as the root user to get the ID. Yeah, here you can see account identifier. Here you can see account ID and canonical ID. So you need to provide the canonical ID of the other AWS account and what access you want to provide. So like for access management, for cross account access, ACL is very easy. Okay, you don't have to write anything. You don't have to write the JSON policy, right? Just by a few clicks, you will be able to grant access. Whereas in bucket policy, you have to write the JSON code, right? You have to write the JSON code, and you must have understanding about these actions, principles, right? Whereas ACL is very user friendly. Okay, but it has limited features. Whereas bucket policy is very extensive, right? And we can also use the AWS policy generator, which we saw in the IM. Okay, like here we can choose the type of policy. Let's say we want to create a S3 bucket policy. Then what kind of access we want to grant. what kind of access. Let's say create bucket, ARN, let's say for all buckets, generate policy. So this is the bucket policy. So with this also we can generate the bucket policy just by few clicks. Okay, do you have any questions still here about bucket policy ACL?
Nope.
Are you familiar with CORS?
With what?
CORS, CORS.
Oh, of course. Yeah.
Yeah, so with CORS basically we can uh, share access to multiple domains, right? Like we can, let's say if a request is coming from some other origin, okay, unverified origin, okay, from an unverified domain, okay. So basically, it's more for restriction of access, restriction access of like it's like more like only verified or whitelisted whitelisted clients or whitelisted domains can only access, right? Like in MongoDB or maybe I mean in Node.js, like when we create the API. So in that also basically we create a CORDS policy, and in that basically we give the requester, like we add like CORDS header. We basically add a header that which domain will be allowed to make an API call, right? So there basically we add a domain, right? So the same way here also in CORDS basically we can, if we are going to use integrate the S3 bucket with our application, right? Let's say we want to store any data which is stored in our application to the S3 bucket. So in that case also we use codes, and in codes basically we whitelist our domain, okay, and then that specific domain will be able to perform XYZ operation. Okay, that operation basically also we can define like what operations will be allowed. It's more application access. Let's say application A wants to talk with the S3 bucket. Okay, so what kind of access we want to provide, those things basically are configured in this CORS policy. Yeah, here you can find this is the CORS policy. Okay, earlier we used to have XML. Right now, the last time I saw they have removed XML. Now only JSON is supported. Okay, earlier they used to have XML also. Now XML is not supported, but XML is much more clear as compared to JSON. Okay, so here basically we have to just give the origin, like which origin to allow. Let's say we want to allow this domain to access the data inside our S3 bucket, and what operation we want to perform: put, post, delete. Okay, then for this domain, we can basically we do whitelisting, like a specific, if the request is coming from a specific origin, from a specific domain, or from a specific server. So what operation we want to allow. Okay, this is more in terms of application access, okay, which is HTTP access. Okay, if the request is coming through HTTP, then what actions should be allowed. So those things are managed by CORDS policy. And currently AWS supports JSON format policies. Okay, XML that is deprecated now. Earlier they used to have XML policy. Okay, do you have any question in cards?
Nope.
Okay, now if we go to metrics, so here basically we can see the analytics, like what is the bucket size, like how much data is stored inside our S3 bucket currently, the number of objects which we have in our S3 bucket over time. Okay, this is basically showing of last 7 days. Okay, the number, what is the bucket size, what is the number of objects inside it. Okay, this is also recently added. This is basically added in the end of 2020. Okay, then we have life cycle rules and replication rules. Are you familiar? Uh, are you familiar with any of these life cycle or replication rules?
Yeah, so life cycle is how long you want to keep the data. I'm not sure about replication though.
Yeah, so with life cycle rule, basically we can set a retention, like how many days we want to keep the data. Let's say we want to keep any data which is created in our S3 bucket, we want to keep it for 30 days, and after 30 days the object must be expired and deleted. Okay, plus like we can perform deletion with the lifecycle rules, plus we can change the storage class also of the data. Let's say any data which is stored inside the S3 bucket for 6 months, automatically it should be transferred to, let's say let's say to Glacier. Okay, those things we can configure using the lifecycle rules. Okay, two things we can set. One is deletion, one is changing the object class, object storage class. Okay, let's say this one, let's say my, okay, then we have to add a rule scope. Okay, in rule scope, basically we can set this rule for a specific object or for a specific folder. And with this, the second option we can set apply it for the whole S3 bucket. Okay, let's say we want to apply for whole S3 bucket. Then action. Okay, there are two major action. One is deletion and another is changing the storage class. Okay, yeah, here you can see transist current version of object between storage class. Here basically it is showing us two things. One is current version and previous version. So let's say if the S3 bucket has versioning enabled, so it will be having the current version of the S3 bucket, current version of the object, and the previous version of the object, right? So we can set transaction for current version and previous version of the object. And we can also expire the object. Expire the object basically means deleting the object. Then we have permanently delete previous versions of object. Then we have delete expired delete markers on incomplete multi-part uploads. Okay, multi-part, we'll talk about that. It's basically a concept of S3 through which we can upload big files. Okay, the files which are more than 500 megabyte or 1 GB. So AWS recommends using multi-part upload, which is more faster and reliable. Okay, so these two kind of operations basically we can perform. Okay, one is deletion and another is changing the storage class. Okay, let's say we want to change the storage class. Transition current version of objects between storage class. So let's say if we have any data which is stored in standard IA. No, sorry. If we have any data which is stored inside any storage class, and if we want to change the storage class, let's say we want to change the storage class to Glacier. Now, after how many days we want to change the storage class? Let's say we want to change after 365 days, after a year. Okay, so here you can see when the object is uploaded, after 365, it will be transited to Glacier. So these kinds of rules we can create, and with these rules, basically we are performing an automation, right? Automatically the data will be deleted, or automatically the storage class will be changed, right? So any data which will be uploaded to this S3 bucket, and if the data, uh, I would say, is 365 days older, so it will automatically change the storage class of the data to Glacier. Okay. Then we have replication rule. Okay, this replication rule is more called CRR, cross region replication. So basically we saw in S3 we have storage classes, and with storage classes we have replication, right? Like when we upload the data is replicated across multiple availability zones, right? The data is replicated across multiple availability zones. Now, let's say if the region gets down, if the whole region gets down due to some, let's say, natural calamity, if the whole region gets down, so the data will be lost, right? So in that case, we can use cross-region replication. So in cross-region replication, we have a source bucket. Okay, we have a source bucket and we have a destination bucket. Okay, destination bucket, or we can call it as a backup bucket. Okay. Prerequisite of this replication rule is, this is basically called cross region replication. Okay, cross region replication. So this and the prerequisite, both the regions of the S3 bucket should not be identical. Okay, should not be the same. So let's say if the S3 bucket is in US East 1A, so this bucket should also not be in the same region. Okay, if it is in the same region, then actually we are not solving the problem. The problem is of disaster recovery. Okay, we are basically trying to solve disaster recovery. If one of the region gets down, so we should have the data in some other region. So this bucket will be in some other region, okay, or it could be in some other geographic location. And once we enable this rule of cross-region replication, so basically we have to choose the source bucket and destination bucket. And once we enable cross-region replication, any data which is uploaded in this S3 bucket will be automatically replicated to this S3 bucket. So any data which we are going to store here will be replicated in this S3 bucket. Okay. So any data which we are storing here will be replicated here. But any data we are storing here will not be replicated here. Okay. It's only one way. So if any data created here, it will be replicated here, but it will not, if any data is created here, it will not be replicated here. And the time frame is same. It takes, not same, it takes 15 minutes to replicate the data. From one region to another region, it takes 15 minutes to replicate the data, and also it depends upon the object size. Okay, also it depends upon the object size. And to create the cross region replication, we need two S3 buckets of different regions, plus we need an IAM role. Okay, we haven't talked about IAM role. Okay, now let us talk about IAM role. So IAM role is basically, we can say, it basically allows two services. Okay, two services in AWS to talk with each other on our behalf. Okay, not two services, it could be the same service. Now let's say in this case, we want S3 to automatically copy the data from this bucket to this bucket, right? Now to perform this operation, S3 basically requires some privileges, right? It requires some privileges. Okay, or else someone manually has to do it. One IAM user, we have to create that IAM user will log into the account and will manually copy the files which are in this bucket to this bucket, right? The user is going to perform that manually, but we are going to automate it using cross-region replication. Okay, cross-region replication rule. And in cross-region replication, what AWS is going to do, AWS is going to copy the data which is stored inside our S3 bucket to another S3 bucket, right? And this part basically requires some privileges, right? It requires privileges. What privileges? Like copying the data from this bucket to this bucket, it requires some privileges. So those privileges basically we are providing using IAM role. Okay, those privileges basically we are providing through IAM role, so that these two buckets can, this bucket can transfer the data to this bucket. Okay, and if we talk in terms of two services, let's say we have a EC2 instance, and we want the EC2 instance to talk with our S3 bucket. Okay, we have a EC2 instance and we want our EC2 instance to talk with our EC2 instance. Sorry, to our S3 bucket. So in that case also we can use a IAM role. Okay, first let us see this one, then we'll see how we can use IAM role in EC2. Okay, also there is one more thing, like if let's say this is an S3 bucket and if it already has a lot of data inside it, and after some time we are, let's say we have created this S3 bucket and we have stored 50 files inside this S3 bucket. And after some time after, we basically plan to create cross-region replication. So we created one more bucket and we enabled cross-region replication. So at the point when we start cross-region replication, so any new data which will be uploaded to the S3 bucket will be transferred to this bucket. Okay, existing data will not be transferred. Okay, let's say if we have a 50 file existing inside this S3 bucket, those files will not be replicated. Okay, so for that basically we have to manually do it. Okay, that basically we have to manually do it.
Is there any, I guess, built-in or automated way to do this, or is this always like you have to go in and set it up and choose, when you want it transferred?
We need to create the replication rule. Replication rule will actually do this. This is automated only.
Okay.
You mean like copying the existing data?
No, I mean just in general with cross-region replication. There's no, I guess, set way to do it where you would just, go in and just say that you want this to happen, and like AWS decides, like, okay, every time something is added to the source bucket, it's automatically copied into the destination. There's no way to just choose something like that. You have to go in.
we can set that also. Let's say at the time of creating the replication rule, we can set that. Yeah, let's say, yeah. So here we just need to give the replication rule name. Let's say my rule status is enabled. Then the source bucket. Let's say this is our source bucket, and this is in Virginia. And then here we can set the rule scope. Like we want to only enable this rule for a specific folder inside our S3 bucket. Or if you want to enable for the whole bucket, that also we can do. So here we can restrict the access. Not restrict the access, restricting the replication of the objects. We can also limit it by tags also. It will check the tag of the objects. If the tag matches, then only it will replicate. Then the destination bucket. Destination could be in the same region and it could be also in some other AWS account. If you want to enable one, yeah, there is one more prerequisite, which is both the buckets must have versioning enabled. Both the buckets must have versioning enabled. Both the buckets must have versioning enabled. Because this bucket has versioning enabled and the destination bucket doesn't have versioning enabled, and that also we can enable just by one click. It will be enabled in that count. Then it requires a IAM role to perform the copying part, replication part. So we need to create an IAM role. So currently we have an IAM role that we can use. So if we go to IAM, go to roles. So here we need to click on create role. Then we have to choose the service, for which service we want to create the role. So in our case, right now what we want one S3 bucket to replicate the data to another S3 bucket, right? So which service we are talking about? We are talking about S3 service. So here our use case will be S3. Okay, and then what kind of operation we want to perform? So we want allow S3 to call AWS services on our behalf. We'll go with S3. Then what kind of operation we want to perform? We can create a custom policy. So currently we'll use the full access, AWS S3 full access. S3 CRR. Let's say created today. Then create role. Okay, and here if we need to refresh, so we'll be able to see that role, the one which we created. And if you want to enable encryption, like the data which is replicated, if you want to encrypt it, so we can encrypt it also. And also we can change the storage class of the replicated objects. Okay, and also here we have an option of replication time control. If we enable this, any new object will be replicated within 15 minutes. Okay, and it comes with some, we have to pay some additional fees as well. Okay, now let's say any data which we are uploading to this bucket will be replicated to that bucket. So let's say if we are uploading, let's say a file called file.txt, upload, and the destination bucket we chose was this bucket, let's learn tech AWS. So currently we cannot see it. It will take some time, 1-2 minutes, depending on the file size. File was very small, but still it will take some time. Yeah, here you can see the file is replicated, file.txt. And here you can see replication status, it is a replica. Okay, do you have any questions till here in S3?
Nope.
Okay, so in terms of S3, in the certification exam, most of the questions will be around storage classes, and there will be some questions around cross-region replication, lifecycle rule. Those will be more questions related, more scenario-based questions, and there may be questions related to versioning and static web hosting, right? And related to bucket policies, ACLs. Okay, so mostly the questions will be around those, those areas. And also limits also, like how many S3 buckets we can create, what is the maximum upload size. Okay, so we have one more concept left in S3, which is multi-part upload. Okay, multi-part upload. So let's say if you want to upload a very big file, you want to upload a file of 5 GB. Okay, and if you are uploading that file, and let's say 90% upload is completed. After 90% of file is uploaded and our internet connection got lost. So what will happen? The data which was uploaded to the S3 bucket will be deleted, and we have to start the upload from zero. Right? So in that case, we can use this concept of multi-part upload. With multi-part upload, let's say we want to upload a file which is of 1 GB. So what it does, it basically creates chunks of that file. Okay, if the file is of 1 GB, so basically we can define the chunk size. So let's say we'll create a chunk of, let's say we want to create 10 chunks of 100 MB each. So what it will do, it will create small chunks of that file, and it will start uploading those files parallelly. Okay, and if one of the upload fails, okay, so what it will do, it will try to upload that particular part again. It will not start uploading the whole file again. It will start uploading that particular part again. And once all the chunks have been uploaded, then it will combine that file. Okay, this is basically the concept of multi-part uploading. It basically saves times and it is more reliable. Okay, if we are uploading a very big file of 100 200 GB, and if we have a very less internet speed, okay, so in that case we can use multi-part uploads. Okay, and it is more faster and it's more reliable. It's also recommended for like 100 200 MB files also. Okay, 100 200 MB files we can upload within 1 minute inside the S3 bucket. But if we are doing it with S3 multi-part upload, so it is fast also, it is more reliable than going with the manual upload. And multi-part upload can only be performed using the AWS CLI. We cannot do multi-part upload using the AWS console. Okay, multi-part upload is only done through the AWS CLI. Yeah, let's say upload the file using, there's a large file you want to upload to S3 bucket. Yeah, S3 API create multi-part upload, bucket name, and the file name. So this is only performed using the AWS CLI. Okay, it is more trusted and more reliable way to upload file to our S3 bucket rather than using the AWS console or using the AWS CLI. Direct upload using the AWS CLI. Okay, so for your reference, I'm sending some links. Actually, this information you'll find in the book also. Okay, so far in S3, do you have any question?
Nope.
Okay. Okay, so then we are good with S3. Okay, now we'll start with the Route 53. Do you have any idea about Route 53? Tyler, do you have any idea about Route 53? Hello?
Hey, sorry, I lost the window for a minute there. Yes, it's a domain name service.
Mhm. Okay. Yeah, so Route 53 is a DNS service of AWS. And there is a reason why there is a reason of this name, Route 53. Okay. So the first thing is this number 53. Do you know what this number is 53?
I do not.
Yeah, so route 53 is basically the DNS port, DNS service port, we can say. When we set up a DNS server, so the default port of DNS server is 53. Okay, like Apache, it's web server. Web server works on port 80, right? The same way DNS server basically works on port 53. Okay, it works on port 53 and it works on both TCP and UDP protocol. Okay, and the reason we call it as root is because of routing policies in route 53. Okay, in route 53 we have routing policies. Okay, that is something which makes route 53 different from other domain providers. Okay, so it's basically a DNS service. Okay, we can also call DNS service, we can also call it as a domain registrar. Okay, what is a domain registrar? Domain registrar, from domain registrar basically we can purchase domains, right? Like some of the popular domain registrars are GoDaddy, we have Big Rock, Namecheap. Okay, I think we can also buy from Bluehost. Okay, so these are some of the popular domain registrars, and from these domain registrars basically we purchase domains, right? We purchase domains. Okay, we purchase domains and we host domains. Host domain, it means we create DNS records, right? We create DNS records. So same way, route 53 is also a domain registrar where we can create, we can purchase domains. Okay, we can purchase domain and then we can host the domains. Okay, so in route 53 basically we have the concept of hosted zones. So once we purchase a domain, we create a hosted zone. Okay, and there in route 53 we have two types of hosted zone. One is public hosted zone and one is private hosted zone. Okay. One is public hosted zone and one is private hosted zone. In public hosted zone is basically designed for public domains. Okay, public domains like the domains which we have purchased. Okay, the domains which you own. Okay, public hosted zone is for the domains which we own. Okay, the domains which we own means the domains which we have purchased. So for that basically we create private hosted zone. Public hosted zone. Whereas private hosted zone is for, it's basically private, basically means internal. Okay, it is internal. It, okay. Whereas here in public domains, it spans across the internet. Okay, it spans across, or it is accessible over the internet, which public hosted zone. Whereas private hosted zone is internal and it is only accessible inside the VPC network. Okay, it is only accessible inside the VPC network. And domain name, any domain name can be used. Domain name can be used. Here we don't have to purchase any domain. No need to purchase a domain. Okay, in private hosted zone, you don't have to purchase the domain, and it is only accessible internally inside the VPC. In the private network, it is only accessible inside the VPC private network. It is not accessible over the internet. Whereas public hosted zones are accessible over the internet. Okay, and for public hosted zone, first you have to purchase the domain. Okay, and it will be accessible over the internet. Any domain which you purchase will be accessible over the internet. Whereas in private hosted domain, you don't have to purchase the domain. Okay, and it only will be accessible inside the VPC network. Okay, and in these hosted zones, basically what we do, we create DNS records. Are you familiar with DNS records?
Yes. Oh, records. Yes. So that's
Yeah,
like.
so we have a record, 4 times a record, CNAME, we have MX, TXT record, SOA record, and we have NS record. Okay, A record is for IPv4 address. 4 times A is for IPv6 address. CNAME is for subdomains. Then we have MX records for mail servers. Text record, TXT is basically TXT record, text record, which is used for verification purpose, domain verification purpose. Domain verification. Or we can say third-party verification. Third-party verification. It's for third-party verification. Then we have SOA. SOA is start of authority. And NS is the name server. Okay, start of authority and name server is managed by the DNS provider. Okay, this is managed by the DNS provider. So in this Route 53 case, these records will be managed by AWS. We cannot delete these records. These two records are managed by AWS, whereas these records are managed by us. We create A records, 4 times A, CNAME record, MX record, TXT record. Okay, these are the common records. Okay, and these records can also be asked in the certification exam. Okay, like which record we can use for IPv4 address. So we have A record, CNAME, MX, text record, SOA, NS record. Okay, so in these hosted zones, basically what we do, we create DNS records. Okay, so if we go to the console, so first what we have to do is, before creating an hosted zone, okay, by default you will not see any hosted zone. So first, let's say we want to create a public hosted zone. So in that case, we have to first purchase a domain. So if we go to registered domains, so we need to register a domain. Now the domain will completely depend upon the use case. Let's say we want to purchase a domain for a company. Okay, or let's say we are creating our own application and we want to create a website for that application. Okay, so depending on the application name, we'll be choosing the domain, right? And domain must be globally unique. Okay, Route 53 also, here you can see it is a global service. It doesn't require region selection. Okay, so domain name must also be unique. You cannot choose google.com. Why? Because google.com is already in use. Okay, it will basically show the availability, whether it's available or not. So here you can see google.com. Google.com is unavailable. The reason is google.com is already in use. It's already purchased and it is already in use. Let's say Facebook. So these domains which are already in use, we cannot purchase those domains. So our domain name must be unique. Let's say so if our application is related to Facebook and it is more also related to, let's say, Facebook security, so we can use this domain name, cyber Facebook. Okay, or any domain depending on our application or depending on the company name, we can purchase a domain. Okay, and the root domain also you have to purchase, let's say facebook.com, .net, .org, .com.au. Okay, these are basically the standard domains. These are basically based on country name. Let's say .au is for Australia, UK is for United Kingdom. Okay, .ca is for Canada, .us is for United States, EU is for Europe. Depending on the industry, also we have capital, Canada's, careers. Okay, so first we have to choose the domain, then continue. Then we need to provide our details. Let's say the company details. We need to provide the first name, last name, organization name, email address, phone number, address, country, state, city, postal code. So we have to basically provide our details. Okay, once we provide our details, then we have to basically do the payment of the domain. Okay, once we provide the contact details, verify purchase, basically the review window where basically it will show which domain you are purchasing and your contact details, and then you will find an option to purchase. And once you click on purchase, it will go to your billing. So from your billing, first you have to purchase that domain. And once you purchase the domain, within 24 hours it will be activated. Okay, within 24 hours it will be activated. Okay, within 24 hours it will be activated. And once it will be activated, you'll be able to see here in registered domains. It will take at least 24 hours. I mean, within 24 hours, basically AWS will activate it. Then once the domain is purchased, then the next step is to create the hosted zone. Here we'll click on create hosted zone. Then if we have purchased the domain, let's say if you have purchased the domain in Route 53, then you can provide that domain name. Okay, let's say cyber.com. Then which kind of hosted zone we have to create? Like here we can see the two types of hosted zone as we discussed: public hosted zone and private hosted zone. Public zone hosted zone is routable over the internet. Okay, but you need a unique domain. Okay, and to get the unique domain, you have to purchase the domain. Whereas in private hosted zone, you have to choose the region and VPC, and it will only be accessible in that specific VPC. And in case of private hosted zone, you can use any domain name. You can even use google.com. Okay, in case of private hosted zone, you can use any name. You can use google.com. Any name you can use. Then you have to choose the VPC and then create hosted zone. In case of private hosted zone, and in public hosted zone, we even don't have to do that. Okay, then create hosted zone. So as we are creating the private hosted zone, so it has created for google.com. Okay, and these are, here you can see when we created the hosted zone, two records are automatically created. One is NS record and one is SOA record. Okay, and these two records are managed by AWS. NS record and SOA record. SOA is start of authority and NS is the name server. Okay, and here they have given 4 endpoints. Okay, so here we can now create the DNS records. So let's say google.com, let's say www.google.com, and then the record types: A record, 4 times A record, CNAME record, MX record, TXT record, VTR record. Most of these are not in use, the one which are done. These are most in use: A record, 4 times A, CNAME, MX record, TXT record, and VTR used by DDDS applications. Okay, let's say we want to create a record. So here then we need to provide our EC2 instance IP. Okay, instance public IP or private IP, basically we need to provide. If it is a public hosted zone, then we need to provide the public IP. If it is a private hosted zone, then we need to provide the instance private IP address. Okay. Now here you will see one more thing, which is routing policy, and this is something which makes Route 53 as a, which makes Route 53 different from other domain registrars. Like if we go to GoDaddy, Namecheap, those places we don't have routing policies. Let's say we'll click on create. First we'll go with simple routing. Okay, so our DNS record is created. Okay, so basically we have 6 types of routing policy. Do you have any questions still here?
Nope.
Okay. Okay, so in Route 53 we have 6 types of routing policies. Okay, and we have 6 main policies. One is simple routing, then we have weighted, then we have latency, then we have failover, then we have multi-value. For multi-value, we have geolocation. Okay, so these are the 6 policies we have in Route 53. So first is simple routing. Okay, so simple routing, it means, let's say this is our Route 53 and we have an EC2 instance and there is one user. So user is trying to, and the Route 53 has, like we have a domain, let's say example.com. And example.com is mapped to EC2 instance IP, which is, let's say 10.0.1.0.4. So when the user types on his browser http example.com, so the request will go to Route 53, and from Route 53 it will go to EC2 instance. So this is basically simple routing policy. Okay, and just like we need to create the DNS record, and it will go to the Route 53. From Route 53 it will go to EC2. So this is the simple routing policy. Okay, this is simple routing policy. Now the next one we have is weighted routing policy. So in weighted routing policy, basically we have multiple EC2 instances. Okay, we have multiple EC2 instances. Okay, let's say we have 3 instances. Now in each of the EC2 instances, basically we set a weight. Like let's say we have a weight of let's say we have 3 instances, let's say 100 weight. So the first instance, let's say we set 40 weight. The second instance we set 40 weight, and the third instance we set 20 weight. Now let's say there is 100 users who are trying to access the application. Okay, there is 100 user traffic is accessing the application. So in that case, 40 requests will go to this server, 40 requests will go to this server, and 20 requests will go to this server. Okay, it will distribute the traffic. Okay, this is what basically load balancer does. Okay, but here we can say it is similar to load balancer, but it is not exactly the same what load balancer does. Okay, load balancer basically has security also, like it provides security, it acts as a proxy, the load balancer, right? Whereas weighted root policy, the request will go to the domain, and from the domain, depending on the weights, it will be transferred to the EC2 instances, which are behind it. Okay, so if we go to the console, and if we create a weighted routing policy, let's say we want to create blog.google.com, and we want to create a record, which will be pointing on, let's say, one EC2 instance 10.0.0.10, and routing policy weighted, and in weighted policy we have to set the weight. So let's say 40, and then we can give a name to that server. Okay, let's say server Okay, let's say we can give a server in US East 1. Okay, we can also set health checks. Health check is basically used to check whether the server is healthy or not. If it is not healthy, then it will not send a traffic to that EC2 instance. Okay, we'll talk about that. We'll talk about that when we are going to talk about failover policy. Okay, so we have created one record. Okay, one weighted record. So for the same domain, we can create multiple weighted records. Okay, that is server in US East 2. Okay, but in actual, if we are creating a simple routing policy, so we cannot create more than one record for a domain. Okay, for a domain, we let's say we have created this simple routing policy www.google.com. Now let's say if I want to create one more record for www.google.com, we cannot create if it is created by simple routing policy. Okay, and simple routing policy is the way all the DNS registrar basically works. You go to GoDaddy or any other domain registrars, they basically use simple routing policy. Okay, and as we are creating that weighted routing policy, there we can see two domains which we have created. Okay, so 40% of the traffic will be sent to this IP, which will be the EC2 instance IP, and 40% will be sent to this IP. It basically distributes the weight. If we go here, yeah, here you can see 90% weight traffic to this, 10% weighted traffic to this. Optimal failover. Yeah, so in weighted policy we set weights on each EC2 instances. Then we have latency based. Okay, let's say we have do you have any questions still here about weighted or simple routing policy?
Nope.
Okay, so in latency based, we have route 53, and let's say we have two EC2 instances. And let's say one EC2 we are running in US, and one instance we are running in UK. Okay, and there is one user, and let's say the user is in US. Okay, the user is in US. Now the request, the user types inside in his browser example.com, the request goes to route 53. From route 53, then it will check the latency. Let's say the user is in US. So if the server is also in US, the latency will be less as compared to the server which is in UK. So let's say here if the latency is 50 milliseconds, then here it will be more than, I would say, 100 milliseconds, right? So what Route 53 will do, it will send the traffic to the server which has the least latency. So it will send a traffic, it will send the request to this server. As this server has less latency. Okay, it will send the traffic to this server, the server which has less latency as compared to the server which has more latency. Now, if someone is coming from UK, okay, if someone is trying to access the application from UK, so definitely the server which is in UK will be having less latency as compared to the server which is in US, right? So in that case, the traffic will be forwarded to the server in UK. Okay. So with this, basically, overall, what we'll achieve very less response time of the application. Okay. The application response will be very fast with latency based routing policy, right? Then we have failover policy. Okay, so in case of failover, first let's see. Yeah, this is one good example. This is a different thing. Yeah, this one. So if someone is trying to access www.example.orange.com from Singapore, and if the latency is less, which is in this region Mumbai, so it will be routed to the Mumbai region. Then we have failover policy. Yeah, so in failover policy, basically we have the first thing basically we have to do is we have to enable a health check. Okay, so okay, so we have Route 53, we have two EC2 instances, and there is one user who is trying to connect to the application. So all requests initially will be going to one server. Okay, let's say the server is in US, so it will be sending all the requests to this server, and there will be one more server. This server will be in standby mode. Okay, no request will be sent to this server. Okay, and on this server we'll be having a health check. Okay, what is health check? We'll basically check whether the server is running or not, right? We'll be basically checking whether the server is running or not. If the server is not running, then we'll not send the traffic to this server, and we'll send the traffic to the standby server if the health check is failing. Okay, what is health check? Health check will just check, it will try to, health check will be a bot, and that bot will try to check, for example, it will just try to check whether google.com is accessible or not, which is running on that server. It will check that the application is accessible or not. Okay, there will be a bot will be accessing this domain, and it will check whether it is basically getting a response or not. If it is not getting the response, then it will mark this instance as unhealthy. And once it marks instance as unhealthy, it will fail over to the standby server. And then the standby server will start accepting the requests. Okay. So this is basically more for high availability. Okay. So for failover one, what we have to do, we have to create a health check. Yeah, health checks. Okay, so I already have one health check. So let's say if we click on edit health check. Okay, there are two types of health checks which we can create. One is for the application, one is for the server. Yeah, so if we are creating it for an endpoint, so here we have two types of targets. It can be an IP address. Okay, it can be a domain. Okay, so usually we do not check whether the server is healthy or not. We usually check whether the application is running or not. If the application is not running, then we consider the server is also not running. Okay, but let's say if we are checking whether the server is running or not, and if the server is running and the application is not running, and the health check will always pass because it will say that the server is running but the application will be down. So the best practice is that we set up the health check on the application. Okay, so let's say my health check. Then we have to set a, let's say, endpoint. Say www.yahoo.com. And let's say HTTPS health check. So it will keep on checking. Like we can set the interval, request interval, like how often the frequency. Basically, we can set like after what time it is going to check. And we can also create an alarm. If that health check fails, it will send a notification also, an email. Okay. So once the health check is created, it will take time to mark it healthy because it will basically make an request to check whether the target is healthy or not. Okay, then we'll click on create record. Then let's say failover. Then here we can create two record. One is primary and secondary. Primary is the server which is going to get the requests, and secondary is the failover server or the standby server. Okay, then we have to choose the health check, and let's say server in US. Okay, then we need to create one more record which will be the secondary record. This is the primary record. Secondary record. email check. Let's say server in Ohio. So currently it will only send a traffic to this server. If the server is down, if the health check fails, and it will start sending traffic to this server. Sorry, it will send traffic to this server, which is the primary record. And if the health check fails, then it will start sending it to this server. Okay, and if we go to health checks, yeah, here you can see it is healthy. And once it is unhealthy, it will start routing the traffic to the secondary DNS record. Okay, next we have is geolocation policy. Okay, in geolocation policy, let's say we have two servers. One is in US, one is in UK. Okay, let's say EU West one. Okay, one server is in UK, one is in US, and the user who is trying to connect to the application is from, let's say, let us understand it in this way. So let's say one server is in US and one is in, let's say, in uh, yeah, one server is in US, one is in, let's say, in I would say, yeah, let's say this server is in Japan and this is in US. Okay, and the user who is connecting, let's say the request is coming from a user who is in Japan. Okay, and in Japan, basically the language is different, right? In US we have English, and Japan we have Japanese, right? So what we want is, so if the user's location is Japan, then redirect him. The request should be sent to the Japan server, and Japan server will be having, the application will be having the language in Japanese. And let's say if it is a e-commerce application, it will be having the currency in Japanese currency, right? And if the request is, if the user is from US, so his request should go to the server which is US, where the language will be English and the currency will be in dollar, right? So in that case, basically we use geolocation policy, where we can set the location. Okay, if let's say if the user is from, we can set based on continents, we can set based on countries also, and in US we can also set based on states also. Okay, in US only it's available based on states. So let's say if any traffic is coming from Asia, from Africa, then send it to, let's say, this IP. Okay, let's say server in Cape Town. Okay, it says that DNS name, the record with this name already exists, and hence it is not allowing us to create. Let's say web one. So any request coming from Africa will be sent to this server. Okay, then any request coming from Asia should be sent to this server. So let's say Asia. So any request coming from Asia will be transferred to this server, right? And if any request coming from Africa will be transferred to this server. Any request coming from Asia. So depending on the user location, we can route the traffic to a specific server. Okay, where the application will be having its own language, it will be having its own currency, right? Okay, do you have any questions still here?
No.
Okay. Okay, so mostly in Route 53, the questions will be around what are the types of DNS records, what are the types of routing policies, okay, and there could be one question like which will be related to Route 53 global, I mean, whether it's a global service or a regional service. One question could be about health checks, okay, and yeah, also in terms of pricing, there will no question related to pricing, but per hosting zone, per hosted zone, there is a monthly charge which is of 50 cents. Okay, for each hosted zone, there is a monthly charge which is of 50 cents. Okay, and to delete it, first we have to delete all the records. Then only it will be we will be able to delete. In SOA and in SV records, we cannot delete because those records are managed by AWS. Okay, so we are done with all the major core services of AWS. Now we'll be talking about application services like we have Elastic Cache, we have CloudFront, we have CloudFormation, we have Lambda, and we have yeah, these few services here. Okay, do you have any questions still here?
No.
Okay, so let's have a break of 10 minutes. Sorry.
Okay. 10 minutes.
Yeah. Yep. All right.
All right. Sounds good.
Hi, Tyler.
Hey.
Yeah, hi. Sorry, I think I took maybe more than
Oh, it's okay.
50 minutes. All right. Okay, now we'll be starting with application performance service. Okay, so majorly in the solution architect, basically we have two services. One is Elastic Cache, and one we have is CloudFront. Do you have any idea about Elastic Cache?
Yes. Well, I guess all I really know is that it's a caching service.
Okay. Elastic Cache is, yeah, definitely is a caching service, and it basically stores the cache in memory. Okay, it's basically a in-memory data store. And what does in-memory data store means? It basically stores the data. It basically stores the cache in the RAM. Okay, instead of storing the data inside the disk, it basically stores the data in RAM. And the reason of storing the data in RAM is very fast. RAM has basically read-write speed in gigabytes. Okay, whereas our hard disk, SSD, HSDs, they have basically in megabytes. Okay, and like if we go for the finest SSD, so it has like 1 GB of read-write speed, whereas the RAM speed starts from 2 3 gigabytes. Okay, so RAM is very fast as compared to SSDs. So in Elastic Cache, basically what we do, we basically store the cache. Okay, what is cache? Let's say we have one application server. Uh, yeah, so let's say we have one application server. We have one database. Okay, and we have one caching server. Okay, now this is the front end. And the front end is basically connecting to the back end, and back end is just a SQL database. Are you aware about WordPress?
About what?
WordPress.
I don't think so.
WordPress is a very popular
Oh,
CMS.
yes, WordPress. Yes.
Yeah, WordPress. Yeah, so WordPress has basically the front end and the back end, which is basically the MySQL database, right? And front end is basically in PHP. Okay, both front end and back end is basically in PHP. Front end basically they are using HTML, CSS, JavaScript, and PHP for bringing the data from the back end. Yeah, so they have front end which is in PHP and one in, and the back end. Database they have MySQL. Now let's say there are thousands of requesting coming to this server. Okay, and users are accessing the website, and the users are basically requesting some data. Okay, and that data is basically stored inside the SQL database MySQL. So let's say when one user is requesting some data, okay, so per request to fetch the data, let's say is 1 second. Okay, 1 second is a very big time. It would be 1 second, let's say 20 seconds, 20 milliseconds. Okay, so one for per request, it is basically taking 20 milliseconds. Like one request when goes to the server, it goes to the SQL database, and the response from the database is within 20 milliseconds. Okay, 20 milliseconds. Yeah, per request it is 20 milliseconds. Okay, and for the server to request one request, okay, it basically takes, let's say, 100 milliseconds. Okay. Now what we want to do is, and 100 millisecond is basically, let's say it's a very big time for the application to respond, to give a response, right? So in that case, what we can do is, if there is a application which is basically hundreds of users are basically trying to access something which is uh, which is the same thing which hundreds of users are trying to access. Like let's say we have a let's say a football match, okay, and the site basically is displaying the current stats of football, like current score, current goals, those things basically it is showing, okay, and which players are playing and what is the status of the match, it is showing, right, live. So for every one request, it is basically going to the database, fetching the data, and then displaying on the dashboard, right? Yeah, in the dashboard or on the website, right? So for every one request, it is basically taking 100 milliseconds. So in that case, what we can do is, and the query is the same. Okay, hundreds of users are basically accessing the same page to check the starts of the match, right? Now in this case, the query is same. Okay, if the query is same, the response will be the same, right? All the users will be getting the same response. So what we'll do is we'll send one request to the server, to the database, and that response of the database will set it, store it inside the to the elastic cache. Okay, in elastic cache, basically we have two caching engines, two types of caching engines. One we have is Redis, and one we have is Memcache. Okay, Redis is also a database. It can also be used as a caching server, and it is also like kind of NoSQL database. Okay, and Memcache is also a caching server. Okay, so these are the two engines which are supported. So for one request, what we'll do, we'll send a request to the RDS database, and the response of that request will store it to the caching engine. Now the second request which is coming to the server, which is the same request, will not send it to the RDS database. We'll directly get the response from the elastic cache, and from the elastic cache we'll be getting the response within, let's say, 5 milliseconds or maybe less than that. Okay, so the response will be fast. Let's say the first request is taking 1 second. So after that, we are basically storing the response in the caching server. And to fetch the data from the caching server, the retrieval is very fast because the data is stored in RAM. So the response time of the application will be very less, okay, as compared to the first request. So in caching server, if we basically see theoretically, so in caching server, we store the frequently accessed data. Okay, in the caching server, basically we store the frequently accessed data. Okay, like let's say hundreds of requests are basically going to the database for the same data. So we basically fetch the data from one request, and that we stored in the caching engine, and then other response basically we take it from the caching server itself. Okay, so we don't have to go to the database. Okay, because in database first it goes to the database, then database basically performs a query, then it basically retrieves the data, and then it sends to the application, right? So the response time from the database is more as compared to the response from the caching engine, okay, from the caching server. So we basically store the frequently accessed data. Now depending on the application, depending on what kind of data we are displaying, so depending on that, the architecture basically keeps on changing, right? So if we go to the console, go to Elastic Cache. Okay, so we have two database engines, sorry, not database, two caching engines. One is Memcache and Redis. And Elastic Cache is a AWS managed service. AWS managed service, it means the underlying infrastructure, the server, the operating system is managed by the cloud provider. Okay, so we don't have to manage the EC2 instance. We don't have to manage the server. Okay, we can also set up Elastic Cache on a EC2 instance also. Not Elastic Cache, I mean these caching engines like Redis or Memcache in a EC2 instance also, right? But but in that case, we have to manage the EC2 instance, we have to manage the server, we have to perform security patches, other things we have to manually perform, right? Whereas Elastic Cache is the AWS managed service where everything, the hardware, software, the operating system, everything is managed by the cloud provider. Elastic Cache is something which is similar to RDS. Okay, in RDS also we don't have to manage the server. We only access the database server. Same way, we do not make any change. We do not manage the server in Elastic Cache. We only access the Elastic Cache. I mean the caching engine like Redis or Memcache. So if we go to the console, if we click on create, so here we have cluster engine, we have Redis, and we have Memcache. Memcache is more for caching. Okay, Memcache is more designed for caching, and it's more for web applications. Okay, whereas Redis can be used for caching. It can be used as a database, and it can also be used as a message broker. Okay, whereas Memcache is mostly designed for caching. Okay, and in Redis we have multi-easy deployment also. Okay, multi-easy deployment, the concept of multi-easy deployment is same as we had in RDS, where we have a standby database instance in some other availability zone, right? We can also deploy it in cluster mode. In cluster mode, basically we'll be having more servers. I mean, there will be a cluster. Behind that, we'll be having multiple servers. Like we can set number of shards we need, number of replicas per shard. Those things basically we can set. Then location, where we have to set up the cluster engine, caching engine, let's say on AWS or on premises. In on premises, basically we have AWS Outpost. Okay, this may not be asked in the certification exam because it was introduced. Yeah, it was introduced in 2020, but yeah, so AWS Outpost is basically having a data center on premise, an AWS data center. Yeah, a rack of AWS data center on premise. Okay, it's basically a dedicated rack in the on-premise. AWS rack on on-premise. So if we have a AWS Outpost on-premise, then we can go with on-premise one. Then the RAIM, say Redis server. Then engine compatibility. These are basically Redis version. Okay, so currently the latest one is 6.x. Then Redis basically works on this port 6379. Like our MySQL database works on 3306, right? So same way Redis runs on this port. Then we have parameter group. The concept of parameter group is same as the concept we have in RDS. So parameter group basically has the RDS Redis database configuration. Okay, because we do not have access to the server, right? We do not have access to the server. So what we do is the Redis server, to make any configuration changes, we basically modify the parameter group, and parameter group basically has the all the configuration. Okay. Then we have node type. Node type is basically the server configuration, and here you will find only memory and network. You will not find the storage. Okay, like what storage you need. So because the reason is because Redis is a in-memory store. So here you will find only memory, RAM. Okay, depending on our use case, we can even get a server of 419 gigabytes of RAM. And it is also the part of free tier. So if we go with T2.micro, which will come with 500 megabytes of RAM, the number of replicas we need. Okay, replicas means basically like it will create basically a kind of load balancer, and behind the load balancer we'll be having the Redis caching servers. So here basically it is asking how many replicas we need. So if we set it to 2, so then it will create 2 replicas. Then if we enable multi-easy deployment, so it will also deploy one instance of the caching server in standby mode. Then VPC, you have to choose the VPC. Sorry, subnet group we have to choose. So we can create a new subnet. Let's say Redis subnet. Like in RDS also we used to create the DB subnet group, right? So the same way here also we need to create the a separate subnet group. Then in which VPC we want to create, and in which availability zone we want to create. Okay, and it should have at least 2 availability zones. Yeah, we can also choose a specific availability zone. If we set it to no preference, then it will randomly choose availability zone. And we can set a security group. And in the security group, we just need to make sure that port 6379 is open. Then we can also enable encryption so that the data which we are storing in our encryption, in our caching engine is basically encrypted. So we can enable storage encryption at rest. We can also enable encryption in transit, which is basically based on user group access. We can also enable logs, what kind of logs we need, and we can send these logs to AWS CloudWatch or Kinesis. And if we have some data which is basically stored in a seed file in Redis, so that all data also we can import. So basically that seed file we need to upload to our S3 bucket, and from here we can import it. Then we have automatic backups. If you see all the settings which we have seen so far, all the settings were same as RDS database, right? All the settings are almost the same as we had for RDS database. Okay, then here we can enable automatic backups, and the retention of automatic backups is 35 days. So we can create backup of up to 35 days, and any backup older than 35 days will be automatically deleted. Okay, if you want to specify a backup window that at a certain period of time, I mean, let's say we want to do it on, let's say, 1 a.m. UTC, so it will only take the backup at that interval only. Then maintenance window. Maintenance is basically for any minor database upgrades. It will automatically apply any minor database upgrades. And then create. Okay, it will take at least 5-10 minutes to create the cluster. Okay, so in terms of the certification exam, mostly the questions will be about scenario-based questions, like which caching engine should be used. Okay, like if the question is talking about dynamic web application, so in most cases we use Memcache. If the question is talking about message broker, if the question is talking about database, so in that case we go with Redis. And in Redis we have a lot of other features also, like we have multi-easy deployment, we have multi-easy deployment, we have cluster mode, right? Those features we don't have in Memcache. Okay, we can also create reserved nodes also, like in AWS. In EC2 we had the concept of reserved instance, right? We also had the same concept in RDS also, of reserved instance, right? So the same concept we have here also. Okay, same offering we have. Okay, this is the one-time payment. And reserved nodes, as we are already familiar, are very cheap as compared to the on-demand instance. Right now, the one which we have created is basically an on-demand node. Okay, here actually we should be able to see the pricing option, but this the one which we have chosen is the on-demand one, where we have to pay an hourly charge. Whereas in reserved nodes we have monthly charge, not monthly, yearly charge, like 1 year or 3 year. Okay, and we have to pay all upfront, no upfront, and basically we have three payment options. One is all upfront, no upfront, and partial upfront. Then we have backups. Once the Redis cluster will be created, we can create manual backups. Okay, manual backup is nothing but snapshot of the database, snapshot of the caching engine. Then we have parameter group. Okay, parameter group is basically for configuration, right? Let's say if we choose this one, so it will show the configuration, chunk size, configuration max. And all of these changes basically requires reboot. Okay. So this parameter group is same as the RDS parameter group. Here we can basically make configuration changes. And here the concept of parameter group is also same, which says the default parameter group cannot be modified. Okay, in RDS also we cannot modify the default parameter group. And in that case, what we have to do, we have to create a new parameter group, right? Then we can create users which will be having access to the Redis database, I mean Redis or Memcache. We can create groups, subnet basically which we created, in which basically the caching engine is running in. And here we can see the events. Like we created the cluster and what yeah, so it says the cache cluster does not support persistence. Please use a different instance type to enable persistence. So this is actually caching server, right? And caching server doesn't have, uh, yeah, as we are already familiar, there are two types of memory, uh, primary and secondary. Okay, not primary, secondary, volatile memory and non-volatile memory, right? And RAM is a volatile memory, which means if there is a power failure or if there is a reboot, so the data which is stored inside the RAM will be deleted, right? And if we and our hard disk is basically a non-volatile memory, which means the data which is stored inside the disk, if the server, if there is a power cut, network failure, or if the system is shut down or restart, the data is not lost, right? That's why it is basically talking about non-volatile, volatile, persistence and non-persistence. We also have non-volatile RAMs also, but it is not supported here in Redis and Memcache. Then to integrate with application, Elastic Cache basically is integrated with applications only. So we have clients like .NET client, Java client, PHP, okay? And depending on the application, we have modules also, like in Node.js, we have modules which we can use to integrate it with Redis or Memcache. Yeah, now it is ready. It is in running state. And here is the endpoint. Like in RDS also, we used to get an endpoint through which we used to connect to the RDS database. So the same way here in RDS, Redis also we have a endpoint. Through this endpoint, we can access the Redis server. And if we click on it, we have three instances running. One is the primary and two are the replica. Replica will be having the same data which the primary has. It's basically for high availability and for uh, request distribution, load distribution. Okay, do you have any questions still here?
Yeah, so you're connecting it to, I guess I'm a little confused as to how Memcache connects to your, let's say, database or front end or whichever. I guess I'm just confused as to how those connect.
Yeah, so
Is it like the same VPC and I just don't have a clear idea of that.
yeah, so in WordPress we have a plugin to do that,
Okay.
and for let's say PHP we have the Okay, in Node.js also we have Redis client. Yeah, caching in Node.js using Redis. So instead of using Redis, we are in cloud. We are going to use this Elastic Cache. There you can see the same port 6379.
Okay, so it's like a package that you would install and then you configure it.
Exactly. Yeah, npm install Express Redis.
Okay.
Express is Redis basically. And
And
Axios,
then,
I don't know what it is.
and then you decide which requests are handled with Memcache, or does it?
Exactly. That we need to set. It completely depends upon the application actually. What kind of queries basically we want to cache.
Okay. And it does it have to be so once you cache it, like how often is it updated? So if
That
it's
also we can set. Like we
okay,
can set every hour, or we can also set if there is a change made on the database, then to update the caching server also. That also we can set.
okay, cool.
Yeah, WordPress also AWS has given an official. In WordPress, there is a plugin that needs to be installed.
Hmm.
Yeah. And we need to provide the endpoint in the application. Let's say this endpoint
Okay.
to connect to the Redis server. Okay. Do you have any questions in the Elastic Cache?
No.
Okay. Now let us talk about CloudFront. There will be two or three question, not more than two or three question in Elastic Cache. Okay, so to understand CloudFront, we will take our that S3 bucket static web hosting, and we'll cache that web hosting using CloudFront. Okay, before that, let us talk about what is CloudFront. Okay, so CloudFront is a caching service. It is a content caching service. Okay. It is a content caching service. We can cache static and dynamic content both. Okay, we can cache static and dynamic content both in CloudFront. Okay. In CloudFront, basically we have edge locations. Okay. So far we were familiar with the regions and availability zones, right? We used to have region, and region we used to have availability zones, right? Let's say this is US East 2, and this is the availability zone 1, US East 1, 2A, US East 2B, and US East 2C. Okay, so we have 3 availability zones. Okay, so currently we are only familiar with regions and availability zones, right? So apart from regions and availability zone, AWS also has edge locations. And like currently we have 24 availability zones, regions, and 160 plus availability zones, okay, all over the globe. And edge locations, we have we have 250 edge locations. So as compared to regions and availability zones, we have more edge locations. And what are these edge locations? Edge locations are basically the sites where uh, basically basically AWS caches the content. Okay, if we see, oh, yeah, they have 225 plus, yeah, 225, around 225, 215 plus edge locations, and 13 region mid-tier caches in 90 cities across 47 countries. Yeah, so here you can see region, I mean edge locations, multiple edge locations, and regional edge caches. So they have all over the globe, they have edge locations. And what these edge location does, they basically, I mean, when we basically use CloudFront, in CloudFront basically we have to choose a origin. Okay, there are, like, we can choose load balancer as a origin, S3 bucket as a origin. Okay, we can choose API gateway as a origin. Okay, API gateway is a service of AWS through which we can create APIs. So we can also choose API gateway also as a origin. So when we choose these as origin, so what AWS does is, AWS CloudFront does it basically caches the data. It basically caches the data across the edge locations. Okay, so let's say if we take an example of this, let's say this one. Here is one good diagram. Okay, anyways, currently I'm not able to see that image. That image is a very good. Okay, so basically what happens in CloudFront is it basically caches the data in edge locations. So let's say we have, okay, let's say this is the globe, and we have created one S3 bucket. So in CloudFront, we need a origin. Okay, we need a origin. Origin can be cloud. Origin can be load balancer, AWS ELB. It can be, sorry, it can be S3 bucket. It can be API gateway. Okay. So first we have to set a origin. Let's say we choose S3 as our origin. Then in S3 we have to tell which content we want to cache, like which data we want to create a cache. Okay, in S3 bucket basically we have static content, right? Like images, PDF, documents, videos, right? Okay, so what we do is we basically, yeah. So let's say we have a bucket which we have created. Let's say in UK. Okay, we created an S3 bucket in UK. Now, let's say users are trying to access from the web application. They are trying to access a video, which is stored in the S3 bucket, and the users are across the whole globe. Let's say some are in, let's say in Brazil, some are in US, some are in, let's say in India, some are in Australia, some are in Africa. Okay, um, some are in UK. Okay, so all of them are trying to access the video. So if we don't have the concept of CloudFront, so the request would be directly going to the S3 bucket. All the users' request would be going to the S3 bucket. Okay, and let's say this user is in Australia and it's located far away from where the data is stored in S3 bucket. So there will be a delay. Okay, like there will be latency, response time, right? Lots of things will be there. The application will take time to load, right? Now to overcome this, we have CloudFront, and in CloudFront, what CloudFront will do is CloudFront will create in edge locations. Okay, in every location basically we have edge locations. So in all the edge location, what it will do, it will create the same data which is stored inside the S3 bucket. Okay, let's say we have some data stored inside the S3 bucket. So the same data, what it will do, it will cache across all the edge location. Now instead of accessing the data from the S3 bucket, it will access from the nearest edge location. It will access it from the nearest edge location. And the edge location, it gets updated every 24 hours from the origin, from the source. It keeps on updating every 24 hours. And we can also manually we can also expire the data which is stored inside the edge location manually. And then it will cache, and then the user will be able to see the updated content. Okay, so instead of storing that, fetching the data from the S3 bucket, it will basically fetch the data from the edge location. And through the edge location, the data will be accessible. And let's say if the bucket is in US, is in UK, and someone from US is trying to access it, so it will be stored in the US edge location. So in that way, the access would be faster. Access would be faster, and the response time will be very less as compared to getting the data from the S3 bucket, which is in UK, right? So we can cache both static and dynamic content in CloudFront. Do you have any questions still here?
No.
Okay, so in CloudFront, basically we create a distribution, which is called CloudFront distribution. Now, till last year, we used to have two types of delivery method. We used to have one web, and we used to have one RTMP. Okay, RTMP is for live streaming, live video streaming. Okay, so AWS actually removed it last year. Last year means like on 1st of January 2021, it was removed. So currently AWS has only delivers only web content, which is basically PHP, HTML, CSS, and graphic files, which could be any static and dynamic content. And the data is basically distributed across HTTPS or HTTP and HTTPS protocols. And it also supports any kind of update, delete operations from the web forums. So first we have to give the origin. So here you can see first it is basically asking the source of the data. So here we can have S3 as a source, load balancer as a source, media package, media store. These are some other resources, okay, which we have to create. So majorly we have elastic load balancer and S3 bucket. So we created one S3 bucket. I mean, we created one S3 bucket and we did web hosting in that S3 bucket. So we'll cache that S3 bucket. Which was this one, my web app. Okay, so what we'll do is we'll use this S3 bucket, which is hosting our website. So here we'll choose that bucket, my web app. Then we can set the origin path. Origin path will be the S3 bucket directory from which we want to fetch the data. Then origin shield is basically an additional option through which we can it's basically a security option, okay, through which Instead of storing the data to multiple edge locations, it will store to a specific region. So then this will be our S3 origin ID, which is the S3 bucket. Then we can restrict the bucket access. And if we are going to restrict the bucket access, then it will be only accessed by CloudFront OAI, which is the origin access identity. So in this, with this, basically what we can do, we can make the bucket private. Okay, then we don't have to make the data inside our S3 bucket public. Okay, so create a new identity and then update the bucket policy, because this OIA will be assumed by the bucket policy.
Can
Then
you
origin connect.
to
Sorry.
once a distribution has been created, can you go back and add an OAI?
Yeah, we can do that. Even after the creation also we can do that. Then origin connection attempts, it's basically uh, the end user. I mean, when we are going to access the data through the CloudFront distribution, it will try to access it for the try to get the response, and it will try for 3 times. If it is not responding in 3 times, then it will time out. Okay, other settings we'll keep it as default. Then the main setting we have is HTTP and HTTPS. So in most of the application, we use HTTPS. Okay, so the URL which will be generated by CloudFront, basically they will generate a domain, and that domain will be able to access through that we'll be able to access the content stored in our S3 bucket. So we can use HTTPS, and that the SSL certificate will be generated and managed by AWS. And what kind of operations HTTP methods we want to perform through the endpoint, so that we can enable here. If it is a API, then we can have put, post, patch, delete. Okay, then we have the main setting we have is, yeah, price class. So in price class, basically we have to choose in which locations we want to perform caching. Now let's say if we have only customers in US, Canada, and Europe, then we can go with the first option. If we have customers all over the globe, then we can go with use all edge location for best performance. Then we can have, uh, then we can also use a CNAME, okay, CNAME of a domain. Let's say cdn.example.com, okay. And in that case, we have to choose we should have our own SSL. Okay, we should have our own SSL certificate. Then the HTTP method, default root object, let's say index.html. Then create distribution. Okay, it will take 5-10 minutes to create, and also it depends upon the data which is stored inside the S3 bucket. Okay, it has generated the domain also through which we can access it. And also in our S3 bucket, if we go to this S3 bucket, we'll be able to see a policy which will be attached. Yeah, here you can see the OAI policy, which is created by CloudFront. Yeah, it is accessible now. Okay, it is still in creation state, but now it is accessible. And here we have HTTPS also generated by Amazon. Okay, just to perform a site comparison, let's say, I mean the speed comparison. So let's say we have the S3 endpoint also, to which we were static web hosting endpoint. Okay, so this also we have, and we have the CloudFront cached also. So let's say if we perform a site comparison, so let's say GT metrics, I mean speed performance, yeah, loading performance. So let's say if we try to check for the S3 bucket one, so let's see the speed, and then we'll see for CloudFront. No, it's deployed. It is trying to test from a server which is in Canada. So the performance is very good. But if we see the overall response time, it took 777 milliseconds to load. Okay, 777 milliseconds to load. And now the same site we will try to compare with another URL. We'll try to compare it with the CloudFront URL. Okay, here you can see it is much better. Hmm, the speed is almost the same. 727 milliseconds performance. Here you can see we can see more green as compared to here, which is less in speed in terms of the one which we have with CloudFront. But here most it is showing better that S3 one.
Oh, well, some of them say that lower is better.
Yeah, lower is better is this one. Lower is better. Higher is better is this one. This one. Yeah, maybe at that time it was not fully deployed. Say if we do the test again, Yeah, now it is showing the right result, 447 milliseconds, and this is 688 milliseconds. Now it is showing much better performance graph. Yeah, higher is better. This is quite big. This is big again. This is big again. Lower is better. So in this also it is good. Lower is better in this. This is ahead. Lower is better in this ahead. Yeah, now in terms of performance, that CloudFront one is better as compared to that one. This is the CloudFront one. Yeah, also after creating, also we can change a lot of settings. We can add domain also after creating. Yeah, you can see why also we can add after creation. Yeah, create a new entity. We can do after the creation also. Yeah, it is showing the hit also on which objects the hit is. How many requests are made. Yeah, so the maximum hits we have in this is the root domain. In this one, robot.txt is the robot.txt even is not accessible because it doesn't exist actually. Robot.txt, favicon.io. Favicon.io should be accessible. Okay, favicon also is not there. In S3 bucket also we don't have the favicon. Yeah, it's basically throwing a 404 error on this favicon and this. Yeah, access also it is showing from which device is being accessed, which browser, Chrome, which operating system, Linux. Okay, so mostly in CloudFront, the questions will be related like what type of content we can cache in S3, not in S3, I mean in CloudFront. So we can cache static and dynamic content both. Okay, there will be questions related to what could be the origins, what are the types of origins which we can have in CloudFront. There could be questions related to OAI policy which we have. Okay. Also, there will be questions related to the expiry. Let's say if the data is expired, which is stored inside our S3 bucket, or let's say it is updated. So how will it be updated in CloudFront? So those kind of questions will be asked in the certification exam. Okay, do you have any questions? Tyler, do you have any question?
Nope.
Okay. Okay, so the next service we have is cloud formation. Are you aware about cloud formation?
Yes, it's a template service, I believe, where you decide. Yeah, it's like templated code to set up services.
Yeah. So cloud formation is basically a infrastructure orchestration service. Yeah, so it's basically an infrastructure orchestration service, and it is actually the implementation of IAC. Okay, what is IAC? Infrastructure as a code. Infrastructure as a code. So in cloud formation, what we do is we create a template, and this template is written in JSON or YAML. Okay, the template can be written either in JSON or YAML. Okay, and in this template, basically we define the resources we need. Like we need a EC2 instance, we need a VPC, Okay, we need a, let's say, S3 bucket. We need to create a CloudFront. We need a RDS database. So we write the resources which we need. We basically write the resource names, and we write the configuration of each of the resources we need. Like what instance type we need, what should be the security group, what port should be open in the security group, what should be the architecture of VPC, like what should, how many available, I mean, how many public subnets we should have, or how many private subnets should we have. Those things basically we write in a template, okay, which is written in YAML or JSON, okay. And CloudFront is something, okay, there would be one or two questions only in the certification exam. But let's say if after giving, let's say, the certification exam, if you join a company, so almost all the company works in cloud formation. If they are using AWS, they may be using cloud formation, or they may be using Terraform. Okay, Terraform is also an infrastructure orchestration tool, which is basically the implementation of infrastructure as a code. Okay. Have you heard about Terraform?
No, I'm not familiar with that.
Yeah, Terraform is a very popular uh, open source infrastructure as a code. With Terraform, we can deploy a lot of infrastructures. Like we can deploy AWS, we can deploy OpenShift, OpenStack, Azure, GCP. Okay, so in AWS we have CloudFormation. Okay, which is similar to Terraform only. And CloudFormation basically makes the let's say if you want to create all these resources, so it will take maybe more than an hour to do that. Okay, more than an hour to create these many resources. And companies basically have multiple AWS accounts. Okay, multiple AWS accounts or multiple environments for running the application, like production environment, staging environment, dev environment, QA environment, right? So they have multiple environments, and the environments are basically replica of. They are basically each other replica, right? Because each of them are running the same application, which is basically used by different teams, right, to develop the application efficiently. So if you want to deploy these resources in one account, let's say it is taking 1 hour. Okay, it will take maybe more than that. And if you want to deploy it in 4 accounts, then it will take 4 hours, right? Plus, now let's say if you want to add one more resource, you want to add, let's say Elastic Cache Server. So you'll add it here, then you have to add in 4 other accounts. Manually you have to do. Then you have to delete one, let's say RDS database, you do not need, no longer you need the RDS database. So then you have to manually go to 4 accounts and manually delete it, right? But with CloudFormation, you can easily create, update, and delete the infrastructure. Okay. Let's say it is going to take 1 hour to create these resources manually. So with CloudFormation, within 15-20 minutes, all the whole infrastructure will be ready. Okay, and if you want to do it for 4 accounts, so currently it was taking for 4 accounts 4 hours. So with CloudFormation, it will just take 40-45 minutes, not for even 40-45 minutes. If we run in parallel in for all the 4 accounts, so within 15-20 minutes, all the infrastructure will be ready in 4 accounts. Okay, because CloudFormation is basically automation. It is basically automating the infrastructure deployment. So in CloudFormation, we write a template. Okay, and CloudFormation is very easy to write. Okay, so in there is a prerequisite of CloudFormation. Okay, there is a prerequisite. The prerequisite is the resource you want to create by CloudFormation. You must know how to create the resource manually. Okay, this is the prerequisite to learn CloudFormation. So the resource which you want to create, let's say you want to create a EC2 instance using CloudFormation. First, you should know how to create that resource using the AWS console manually. If you know that, then you can easily create it by CloudFormation also. Okay, and that is the only requirement. Okay, now once you know that, then you can actually get the code snippet from the documentation. Okay, it is almost impossible to learn the code. I mean this I mean template for each of the services. Okay, because AWS keeps on updating it. Okay, AWS keeps on updating it. Okay, and they keep on adding a lot of other services, right? So here you can find some code snippet. Let's say this is the code for creating a EC2 instance. Okay, here basically we have to write the resource name. Resource name can be anything. Okay, here they have written EC2 instance. We can also write web server. Anything we can write here. Then type. This type is reserved. Okay, this is basically the AWS API, AWS EC2 instance. Then properties. In properties, basically we are basically telling the resource property. Like what should be the image ID, what should be the key name, what should be the instance type, which security group to use, what should be the block device, right? Those things basically we are defining here. Then this is the code to create a elastic IP. Okay, as I said, the resource name could be anything. So here they have given my EIP. This is the API name. Then in properties, like here, which instance you want the elastic IP to be attached. Okay, for all the services, these are basically snippets. We can also, let's say we want individually for EC2. Yeah. So by the API name, we can get all the properties. So this is the code snippet. If you want to create a EC2 instance, so this is in JSON and this is in YAML. Okay, so this is basically the structure. So the type, then properties, like what should be the instance type, security group, host ID. These things basically we can define. What each of these property means. Okay, these are all the properties. Let's say when we are launching the EC2 instance, we have to choose the availability zone. We have to choose the, not all options are required, because and when we create EC2 instance, so most of the options are default, right? And some of them are not required. Image ID is required. Instance type is required. Key name, launch template. Okay, so in cloud formation, basically what we do, we create a template, and with this template, basically we create a cloud formation stack. And stack basically has the AWS resources, like EC2 instance, RDS database, those things basically it has. And when this stack is deleted, all the AWS resources are deleted. Okay, when we delete the stack, all the resources which are created through this stack are deleted. Okay, so let's say if you want to create a EC2 instance, I'll just open Visual Studio Code. You may, yeah, have you used Visual Studio Code?
VS Code?
Yeah,
Yes.
yeah. So in VS Code, we can install some extensions. Let's say, yeah, we'll find an extension of YAML. Yeah, YAML extension and the CloudFormation linter. Yeah, CloudFormation linter. Okay, now let's say we want to create a EC2 instance. So we need to add one resource. Then the resource we want to create, let's say we want to create a web server. So this web server name can be anything. Then type AWS EC2 instance properties image ID instance type. Okay, security group. Okay. Okay, you don't have to learn these things. I mean, this API name properties. I have actually, yeah, you don't have to learn these things. All these things basically we can find in the documentation. So resource, first thing is resource. Okay, this thing is mandatory for every time we have to basically define this resource, and after that basically we start creating the resource. This thing is the resource name. Resource name. This is the resource API. This is the resource property. Okay, image ID. So image ID, we have to use the AMI ID here. Instance type will be T2, let's say T2.micro. Okay, security group is also not required. If we'll not specify the security group, it will use the default security group. Okay, so AMI ID. Okay, so these are the two major things which we need to launch the instance, AMI ID and the instance type. Other things will be default, right? Let's say if I go here and if I just choose the AMI ID manually, and even if I don't choose the instance type, then also it is fine. And if we just click on review and launch, so other settings are default, right? So the same way we are just defining two things. So that's the reason the prerequisite of CloudFormation is the resource which you want to create from CloudFormation. You must know to create the resource by the console. Okay, so this 5 6 line code will deploy a EC2 instance. Okay, so now we'll go to CloudFormation. Then before creating the stack, we'll go to designer. In designer, basically we can validate the configuration. So we'll just copy this. Okay, now it says template is valid. Once the template is valid, then we can basically create the stack. So then create the stack, then we can upload the template file. Currently it has automatically picked from the designer. So what it has done it has basically uploaded to a S3 bucket, and from the S3 bucket it will read it. Next, let's say my stack, and then create stack. And what this stack will do, it will deploy a EC2 instance. Yeah, here you can see it has started creating the EC2 instance, and we'll be able to see the EC2 instance as well. Yeah, here you can see it has started creating the instance. Okay, the instance is in now running state. The cloud formation should be completed. Yeah, create complete. Create complete. Okay, and here in events we can see what it basically tried to create. Now let's say if we want to delete this instance or delete the resources which are created by the cloud formation which are in the stack, we can, if we just click on delete, it will automatically delete this EC2 instance also. Here you can see now it is shutting down and it will be terminated. Okay. So this was a very small example of cloud formation. Okay, in that exam they will not be asking this much, but just to give you an idea about cloud formation. Cloud formation itself is a course. I mean, it has a lot of things like parameters, resources, outputs, functions. A lot of things are there. Okay. Do you have any questions still here about cloud formation?
No.
Okay. Now let us talk about Lambda. Okay, so Lambda is basically the serverless service of AWS, and it basically runs the code in basically containers. Okay, and that's the reason actually Lambda is called a serverless service. Okay, underlying basically they have the hardware, they have the server. Actually, the server is there, but on top of the server, they are running the code in a container. Okay, are you familiar with containers? Docker
Um,
containers?
I am. Isn't it just when you have like a small service and all of its
Yeah,
packages?
microservice kind of thing. Hmm. Yeah. So it is basically the implementation of containers, and you may have used Heroku. Have
Yes.
you used Heroku? Yeah. So Heroku is also using is the same thing, like where we just need to provide our code, and basically Heroku executes the code, runs the program or the application. The same thing basically Lambda does. And Lambda basically runs the application in the yeah. So Lambda basically runs the application. Okay, not the application, I would say a set of code. It basically executes. So there are a lot of things which we can do with Lambda. Like we can perform automation. Let's say in our AWS account, we have two dev servers. And for cost saving, let's say the company wants to they want to create a mechanism that automatically at 5 p.m. when the developer stops working, the EC2 instance must be stopped. And in the morning 10 a.m. when the developer starts working, the instances must be started. Okay. So those kind of things, those kind of automations we can perform using Lambda. Okay. Let's say there are someone is trying to log into the AWS account and there are three invalid passwords. So trigger the Lambda function and Lambda function will disable that IAM user account. Okay. These kind of automation basically we can do using Lambda functions. Okay. A lot of other things we can do, like we can integrate it with S3, as we just discussed. When we were talking about S3 events, we can integrate it with S3. Okay. We can connect it to our RDS database. A lot of other things we can do with Lambda functions. Okay. Lambda function is nothing, just a code which is running, which is going to execute. Okay. Like with like in Python, we have a library called Boto3. Okay, we have a library Boto3. This one is going to read the docs. Okay, so here basically these are basically AWS. Uh, let's say we want to create code examples. Let's say EC2 example, working describing EC2 regions, working with security group. Yeah, so let's say this is the code, and this code will basically give, let's say, create a security group and rules. So this code, what this code can do, this is the Python code. What this code can do, it can create a security group with opening port 22 and port 80 in the inbound, right? So the same way we can perform any kind of automation. This is the Python code. This Python code we can put it in our S3 in Lambda function, and when that Lambda function is executed, it will create the security group. Okay, so we have different types of runtime: .NET, Go, Java, Node.js, Python, Ruby. So this question is directly asked in the certification exam. What are the types of programming languages which are supported in Lambda? So we have .NET, Go, Java, Node.js, Python, and Ruby. Okay, let's say we want to create a Node.js. So in this Lambda function, we have a execution role, which is also called service linked role. Okay, which is also called service linked role. And when is this role in use? Let's say we want the Lambda function to create a security group or to a EC2 instance. So for that, basically, it will require some credentials, some authentication, right? So that authentication, that authorization is basically granted through the execution role. Okay, execution role is just the IAM role. So we have to create an IAM role depending on what Lambda function is going to do. Let's say it is going to create S3 bucket. So we have to create a service linked role, Lambda IAM role that will be having access to S3. And that role we have to attach to a Lambda function. Okay, there is a default Lambda, default role also. And what does that default role does? It basically reads the, it basically creates it basically sends the logs to CloudWatch. CloudWatch is basically the logging and monitoring service. So it basically sends the events to CloudWatch. Then we have code signing, and we can also run the Lambda function in a VPC. Okay, but running the Lambda function in VPC, we'll be only running it in VPC if, let's say, we have some resources which are only accessible inside the VPC network. It's not accessible over the internet. So in that case, basically, we will create our Lambda function in a VPC. Yeah, so there are some limitations in Lambda. Like as we discussed, like if you want to run up application, let's say we want to run a Python program. So there are two requirements. One is one EC2 instance we need, and we need the compiler, right? So we will be launching an EC2 instance, then installing the compiler, and then running the Python code, right? So we basically found an alternative which is Lambda. So we can just upload our code here and we can execute it using Lambda, right? But the problem with Lambda is there are some limitations in Lambda. So the limitations are if the code is taking more than 15 minutes to execute, so Lambda will time out. So max execution time in Lambda is 15 minutes. Okay, the max execution time in Lambda is 15 minutes. So if the program is going to take more than 15 minutes, then we cannot run it in Lambda. Okay, and then we have a resource limitation also. So if the program is going to take more than 10 GB RAM, if the program is going to take more than 10 GB RAM, then we cannot execute it in Lambda. Okay, because the maximum resources which you can define in Lambda is 10 GB RAM. Okay, that we can see from here, configuration. Yeah, so 128 memory. By default, it is set to 3 seconds. We can set it max to 15 minutes. Okay, the maximum timeout is 15 minutes. And memory is 10 GB, 10240 MB, which is 10 GB. Okay, we can also create environment variables, and these environment variables we can call it in our Lambda function. Let's say we want to send some in our Lambda function. We want to pass some credentials. Let's say username, password. So those credentials, instead of directly passing in the code, we can pass through environment variables. Okay, and if our Lambda function wants to connect to the RDS database, and the RDS database is running in private endpoint, so in that case we can create a Lambda function inside a VPC. Okay, and here we can see the metrics. Like how many times the Lambda function is executed, how much memory was executed, what was the success rate. Okay, currently we haven't executed, so it doesn't have those limits, those stats. Logs we can see. Okay, we can also pass a payload variable at the time of executing the Lambda function. That also we can do. Okay, and this is the default function name which will be executed, index.handler, and this handler must be inside our, yeah, here you can see in Node.js, I think it is created this way, exports.handler. Handler is the function name. So it is basically defined here which function to execute. Like if you have ever worked on C, C++, so basically there we have main function, and that main function is basically executed, and that main function basically runs the code, right? So same here, basically we define a function name which will be executed. So index is basically the file name and handler is the function name. Index file name, handler is the function name. So here we are basically telling Lambda when the function will be triggered. So which file to execute and which function to execute, right? Okay. Now let's say we have developed our own module. Okay. Let's say in Node.js we have created our own module, or in Python we have created our own module. okay, and that cannot be installed using npm, right? So in that case, we can create a lambda layer, okay, and in layer what we do is we basically upload the code, the module, okay, and module is nothing, it just has the functions, right, function variables, right? So that module we can upload here in a zip format, and then we can add that layer in our lambda function.
So would that be if you're using like an npm package, and
Sorry.
would that be if you were using like a package, like an npm package, and then
Yeah,
you
yeah,
would?
npm package, let's say npm package we can directly upload. Actually, we can upload the node modules folder here, npm modules folder with our lambda function. Lambda function actually we can, there is a way to, yeah, upload. We can upload it as a zip file. So we can zip up our code and we can directly upload it to lambda here. Okay, we can also do a test run. Let's say test event test, and that will execute the lambda function. And currently it is a sample code, so it says arrow from lambda. In monitor, we will now be able to see the output, the logs, metrics. It basically takes 5 minutes to display 1 hour. Yeah, here we can see the execution result. Okay, do you have any questions still here?
Yes. So if you can upload your code, you can zip it and upload it. What is the layers like? What does that do? I guess I don't understand how
Yeah,
that
layer
ties
is
in.
just, let's say you want to, you have created a custom module. Okay, so that module we can add it as a layer. Okay, and that we can import then. Like in, I don't know in Node.js, but in Python we do import Boto3, import JSON, import the module name, right? First we'll upload it as a layer, and layer is only used when we have our custom code. Okay, the code which is not the module, we have our own module, and the that module is not available in npm. Let's say when we do npm install, that module is not available.
Okay.
Okay. Yeah, this is also a good thing. Yeah, layer, hmm, libraries, node modules, etc., assets. So we are creating a layer, and that layer is basically used by multiple functions. Yeah, let's say we have multiple functions, and those functions want to use the same node modules. So we can create a layer, and that layer will be reading the, the code will be reading the layers. From the layers, it will be reading the modules. Yeah, like multiple functions using the layer. In this way,
Okay.
the lambda size of the lambda function will not be big, or else for each of the lambda function, we have to each of the lambda function will be having the same size if we have the node modules for each of the lambda functions. Okay, do you have any questions still here?
I don't think so.
Okay, let's have a break of 10 minutes and then we'll end up with this last service, which has been start. Okay, 10
Okay.
15 minutes. Yeah.
Okay.
Okay. Yeah. Hi, Tyler. Hello.
Hi there.
Yeah. All right. So we have Elastic Beanstalk. So do you have any idea about Elastic Beanstalk?
Yes, it's used to deploy an application.
Okay. Yeah. So it is basically a service which is for, I would say, is good for developers or good for, uh, yeah, majorly good for developers and for companies who don't want to manage the infrastructure. Okay. So this service is basically for developers and the companies or the individuals who don't want to manage the infrastructure. So here basically what we have to do is we have to just bring our code and basically we have to choose an architecture. Okay, so let's say if we click on create application, let's say my web app, then in which programming language it is written in, let's say it is written in PHP. Okay, let's go with Node.js as you're familiar with Node.js. Then which version of Node.js? Node.js running on Node.js 14 running on Amazon Linux. Okay, then we can deploy our own code. We can upload it to our S3 bucket. Okay, or we can deploy, let's say, a sample application.
What does it mean, a sample application?
Sample application would be like a demo application by AWS. I mean, which will be having, it will be just like Hello World, or
Uh-huh.
of Node.js. Yeah.
So if you want to add your code and replace whatever
Uh-huh.
the sample code is, are you able to do that?
Yeah, we can do that. We can also create different environments, like we can create um, blue green environment, and we can deploy the code without zero downtime just by this console. Okay, and as we are deploying the sample application, so it is provisioning a load balancer, creating a security group, lots of other things that basically it is creating. It's also creating a health check. So it will automatically provision the infrastructure. And in the backend, it basically uses cloud formation. Where you can see it is basically using cloud formation. And this cloud formation is basically provisioning the infrastructure. Okay. So in the backend, they are using the cloud formation. Okay, basically in Elastic Beanstalk, we have status code. Beanstalk status code. Yeah, so we have the status code, instance status, sorry, environment status. Basically, it is environment status. So mostly in the certification exam, the question is asked like, if the elastic, if your elastic beanstalk deployment is showing yellow, so what could be the issue? Okay, and what is the severity level? Okay, it is still under creation, and it has also generated the URL through which we can access it. Yeah, here you can see this is the sample application.
Okay.
Congratulations, your first Beanstalk Node.js application is now running on your own dedicated environment in the AWS cloud. And it has created a lot of resources. It has created a EC2 instance. It has created load balancer. It has created VPC. A lot of other resources basically it has created. If we go to resources, so in total it created 14 resources. Also it created the auto scaling group as well. Scaling up, scaling down policy. Metadata. CloudWatch alarm also it has created. Load balancer security group. If you go to instances, yeah, so here it has one the EC2 instance. And this EC2 instance is behind the load balancer. And this is the load balancer security group. So it basically created all the resources: load balancer, EC2 instances, VPC, auto scaling, right? And the health is now okay. Okay, so basically, this environment health status basically is usually asked in certification exam. Like we have different health colors. Like currently we have OK, green. So the status is displayed when an instance is passing health checks and health agent is not reporting any problems. Most instances in the environment are facing health checks. The health agent is not reporting major issue. An instance is passing health checks and is completing requests normally. Yeah, for example, you're and taking request normally, 5% of requests are returning. Deployment completed normal. Yeah. Then we have yellow. The health agent is reporting a moderate number of request failures or other issue for instance or environment. An operation is in progress or an instance and is taking very long time. Red. The status is where when the health agent is reporting a number of request fails or other issue for instance or deployment. Severe red. Number of request fails, other instances. Hmm. Pending gray. Okay, so these status code are I have seen many times this question. This is something which is usually asked in the certification exam regarding Beanstalk, the environment status. I'll send you on the chat. Yeah, health that is showing okay, not yes. Okay, now here we can upload our code also. We have different deployment policies also. Rolling update, rolling with additional batch, mutate, traffic splitting. Mm. Okay, we can upload the code files. We can also change the server configuration also. Let's say if we go here, configuration. Yeah, here we can see the instance configuration, capacity. We can anytime we can scale up or scale down. Okay, let's say we want to change the instance configuration, security group. You can see the logs. Where we have the server logs and Linux logs, error log, access log, load balancer health check. Here we have my IP address. Hmm, what is okay? Overall health of the instances, monitoring, total response, request, CPU utilization. Okay, so majorly the questions will be around the status of the environment, like and what are the different types of deployments which are available. So let's say if we deploy the code, so we have different types of deployment policy, like roll at all at once, rolling update, rolling with additional batch, immutable, traffic splitting. Like what are the types of deployment policies?
Did you take the instance down?
No, no, no. Showing this way. Yeah, now it is showing. Yeah, so basically we can create multiple environments. Let's say in production environments we have dev environment, prod environment. Yeah, let's say we can clone the environment. Environment name, let's say dev environment. Okay, so it has created the, let's say, the dev environment. And let's say when the code is pushed to the dev environment and when it is running stable, I mean, let's say we have created one, let's say this is the production environment, this is the dev environment. And let's say there is a new application version available. So first we'll deploy it in the dev environment, or we can call it as a staging environment. Once we deploy it to the staging environment, and if everything is working fine, then what we can do is we can swap the URL. Currently, it's not ready. Once it will be ready, then we can make the staging environment as the production environment. So without downtime, the application will be updated. Yeah, now the dev environment is also ready. And we we have the this one. I guess the initiated the. Okay, an Elastic Beanstalk is free to use. We are only charged for the resources which we are running. Let's say load balancer EC2 instance. So we are only charged for those resources.
If you are trying to deploy an application that you don't think has a ton of traffic and you don't think you need like the auto scaling or the load balancers, can you still use Elastic Beanstalk?
Yeah, we can use, yeah, at the time of creating the environment, we can set the configuration. Like, uh, so if we go to this environment, configurations, view changes. Yeah, so we can actually change the infrastructure. Let's say if we don't want load balancer, uh, yeah, actually, in that case, we have to go with this option. Currently, it is not coming up. Platform created and owned by you.
Hmm.
And the reason is, I think they have updated something, custom profile. Yeah, this is the option, but currently it is not coming up.
Hmm.
Yeah, custom platform. In custom platform, basically, they give us the templates, like what kind of infrastructure we want to run.
That's
Application
really odd.
name.
You just can't you can't use that anymore.
We can do that actually. One second. Let's say we want to run Go application 03.3, configure more options. Yeah, here it is shown. Single instance, high availability. Yeah, that thing basically we can choose here. Like we just need to deploy, let's say, in single instance, free tier eligible. Single instance using spot instance, high availability. If we go with high availability, it will configure load balancer. Yeah, high availability using spot and on-demand instance. Custom configuration. In custom configuration, we can manually do our configuration. Okay, sounds good. Do you have any other question? Stuff.
No.
Okay, so majorly in Beanstalk, you'll see questions related to the health checks, environment status, which is green, yellow, red, and yeah, majorly that, and what are the types of deployments available, those things. Okay, okay, sounds good. Do you have any other question in any of the services which we have learned so far?
Mm, no. No questions right now.
Okay.
I'm hoping to take the exam in July. It's my goal. So I'll just keep going through study materials and hopefully
Yeah,
I'll be
yeah.
ready.
Yeah, if you'll just go through that, those questions, so I'm sure 100% you will be able to clear the exam because most of the questions are around those that book only.
Okay. Awesome.
Okay. Yeah. Okay. Overall, how was your experience in the training program?
And which program?
I mean, in this training, how was your experience?
Oh, yeah, really good. Yeah, I think that you presented the concepts really well and like the way that you explain things and yeah, I'm feeling good about it.
Mhm. I think you have given cloud partitioner, right?
Yes.
I think. Okay, so you are going to appear for the AWS Solutions Architect, right?
Yeah, the associate. That's him.
Do you know there is one more certification, Developer Associate?
Yes. So yeah, there's a lot more. But yeah, this was the one that I wanted next was the architect
Yeah, it's
associate
more in
and
demand. Mhm.
yeah. And then I was thinking of just going for the developer one as well, since a lot of those concepts are already covered.
Yeah, yeah, yeah.
Yeah, that's my plan.
Okay, sounds good. So we can wrap up the session here.
Okay.
Okay,
And
and hmm?
you said that would be, or I guess Matt would be sending the videos.
Yeah, yeah, Matt will be taking that. Yeah, and
Okay.
also even after, I mean, the completion, if you go through videos, if you have any question, any doubts, you can reach to Matt, and we can do a doubt session or something like that. That is also fine. Okay.
Okay. That's great. Thank you.
All right. Yeah.
Well, I appreciate it. Thanks for teaching.
Sorry.
Oh, I was just saying thank you for teaching.
Yeah, yeah. No problem.
All right. Well, enjoy the rest of your weekend.
Same to you. All right. Yeah. Okay.
Thanks.
Thanks. Yeah.